One. And we're live, dude. How you doing, my
Yeah,
man?
what's up, man?
Thank you so much for being
Of
here.
course, thank you for having me.
What is that you were saying right before I started?
All right, linguistic professors, they have like there's a it's on some subreddit or some shit, but it's basically you have the profile of the mouth, right? And it's a model, it's not a real.
Yeah.
And they cut it so you can literally see the inside of the mouth, right? And the tongue, you can use your mouse and at rest, your tongue is laying flat in your mouth, right? So if you're looking at it sideways, it's flat on your mouth. But if you move the tongue with the mouse, that's how you get all the
No, you.
yeah, that's how you get all the pronunciations of different languages. So it turns out yes is the easiest thing to say in every language because if you speak Spanish, it's C. So your tongue is all the way back and forward. So when you say C, it's C, 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 C.
Yeah.
And then in Germans, it's all the way up. Your tongue is all the way up. So it's ya. So it's ya, 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 ya. And then the French do it right in the middle. So it's not down, side up. It's right. It's oui, 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 right. So the easiest thing to say is yes in every language because it's literally just your tongue all the way in the back and then in one of the end points of the mouth. And that's when they can prove a social concept is purely based on a biological, like a hard scientific thing. It's like that's why we do it. And like,
Bro,
isn't that crazy?
It's fascinating.
Yeah, exactly.
Like
Yeah.
the last thing that I would think
Yeah.
is that when we're talking in different languages, our bodies are doing the same thing.
Yeah, body language. That's like another biological thing. Yeah.
Yeah.
But it turns out the language itself also derives from a purely scientific. Like it doesn't matter how you say yes. It's because it's the easiest thing to say.
That's
Yeah.
the more I think about it, the more mind fucked I am about
And
it.
it makes sense in the end. It only makes sense in retrospect. That's the problem. Like before you reach the cusp of the answer to the problem, you're whatever, and then you reach the problem, you're just like, and everything behind you, you're just like, we're so stupid. Like, why didn't I think about that? Like, so yeah.
If you were to theorize,
Yeah.
what do you think is the reason for that?
Because
Like, how comes we to express the same shit?
Well, because like, what's the first two things that you would need to communicate between two? Like, let's say you have animals that have not made language. What's the two things you communicate? Either approval or disapproval, right? Mm-hmm. So I feel like yes and no would be the easiest to say in any primitive language. And mind you, I don't have any background.
Yeah, no, absolutely.
Yeah.
And for anybody watching,
but we know that most languages come from either Indo-Asian, which is like all the Hindi, all the Urdu, all the whatever, Latin, which is all the Romance languages, English, Spanish, French, Romanian, Portuguese, whatever, or German languages, German, Dutch, English, whatever. And so if you look at how those dominated, and Asia, but I like they have their own thing, I don't know, whatever. But but how we say yes almost universally is just your tongue going back and then your tongue going at the furthest point it can at some point of the mouth. So
I wonder.
It's scientific. It's not an art.
It's not subjective.
Exactly.
This is
right.
factual.
Yeah, exactly.
It's a thing.
As opposed to like feminine and masculine. Like the complexities are obviously a little bit more societalist, but the very definitive yes and no, science based. Not the.
Do you know if that happened? Like in that you read that on an article?
Yeah.
Did they mention if that happens for anything else? Any other?
I'm sure, but reading about that was enough. Like, Because here's the thing: the reason I never got into, and the reason it's so complex, is if you ever seen the Wikipedia page for the pronunciation. You know how in Wikipedia when you look up a word, it's the word and then it's those weird letters that make you pronounce it.
Yeah.
Well, those weird letters come from a chart, and it's the universal speech pattern, whatever. And so that's why they look like Greek letters. That's why they look like Indian letters, weird, whatever. It's because there's only like 50 sounds that you can make with your mouth, and those 50 sounds things. And those 50 sounds, I never, because the way you pronounce those sounds is it's like it's a O in log, like that's how you pronounce it.
Yeah.
And I can never remember that, you know what I mean? And there's 50 of them, so like I feel like for you to get really involved in that, you have to care because I don't care.
Yeah, now that you mentioned the whole 50 sounds thing, I remember, and obviously this is just some dumb story that I'm adding to it.
Yeah.
But when I was a kid, in more than one occasion, I actually sat for a long period of time. I'm not gonna say 10 hours, but it was
Yeah, yeah.
for a
A
kid.
while.
Sit
A
sit
while.
down for an hour
Yeah,
is
yeah.
is a lot. Thinking that's bro, come on, that's a lot. And I used to just try to fucking create a letter, bro. You ever did that?
Yeah, of course. Of
Bro,
course.
I would sit down and I'll be like, and you know how in Spanish, well, this happens in English too, but in Spanish especially, we have a lot of two-letter sound combinations.
Yes, exactly. Yeah.
Like we have the FRs
Yes.
and the CRs
Yeah.
and so on and so forth,
Yeah.
right? So I would try to like I'll be like, maybe I can't create a new letter because I can't come up with a sound, but maybe if I put two together, I can just make them
Yeah,
sound
yeah.
in the new. Bro, I'm telling you,
Yeah.
it was like a mental game of mine when I was a kid. I was like in seventh grade at the time, and NDR seventh grade. You're okay. You're 6, 7, 8, 9, 10, 11, 12. So I was like 12. I was like 12 years old.
Yeah.
And I couldn't, obviously.
Yeah, of course. Yeah.
but it was fun to try.
The one thing I do, and it's funny you brought this up. The one thing that I did remember spending so much time like contemplating, like a fucking like I was working a PhD, was when you really like a song, like a pop song. To me, it sounded just right, like a Phil Collins, like do 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 do. I was like, that's perfect, and I always thought that that there was this formula that there's only a finite amount of sounds and music combinations that were perfect, because I was like, obviously when he came up with that song, he heard it the first time, I was like, that's perfect, and then we're producing it, and then like whatever. I didn't think about like lyric writing and whatever. So as a kid, I was like, when I first hear a Gorilla song, or I first hear like whatever, and I'm like 10 or 11, and I'm like, that's a perfect song. I get why that's a number one. Like, and it
So
didn't hit
to
me
you,
until-
anything on the first place of Billboard was like a masterpiece.
It wasn't a masterpiece. It was just like it hit me. I guess the dopamine as a kid is so easily reached that I was just like, this is every note is exactly where it belongs, and that's why it's so good. So in my head, I was like, and you know how like in the stories you have like these eureka moments. I was like, they must have been in the sound booth going eureka, that's it, and then they rubber stamped it and then produced it. Like that's how I thought the music industry was like.
Yeah, like
they played random notes and then. Because I didn't know what a chord was when I was a kid.
Yeah,
You
didn't know music theory.
Exactly.
Yeah.
I didn't know whatever. So I was just like, I thought there was just a guy and a guitar and a guy and drums and they're just playing random notes until they hit something and it's perfect, and that's how they make a song.
It makes sense though.
Right.
Like it obviously doesn't happen like that, but it's a nice logical out. You know what I mean? It's a nice. If you sit down and use logic, right, you can get there.
Right.
I can totally see it.
So I always thought, like, you know, like a sweatshop almost,
Yeah.
like just a musical sweatshop where people are just like A B C on the, or like A C B, or I didn't think that the chords 1 4 2 1 existed before, you know. Like
none of that.
But I was like, yeah, that's so the way you were trying to make a new thing. I was like, what combinations are they trying? Like, is there a website?
What if I get there,
bro? I was like, if I get this neck, because I knew you could sell the rights just to I knew the lyrics and I knew the production was different. That was the only thing I knew about the music industry. So I was like, fuck, if I could just make those notes, just sell them. I don't have to play an instrument. I just have to like know the notes, write it down. And then in my head, I was like, you make a hit, you make $10 million. Like you just get, although back then I remember thinking a $100 bill was like,
eternal, yeah.
Yeah, like my mom, the first time I saw my mom get a $100 bill, I was like, we're rich. Like,
we have it.
There must be like 8 of those in the world.
Yeah, it will be. Wouldn't that be fascinating or cool if somebody could like math their way into making a top one song?
Yeah.
Like if
people are running AIs right now to try and.
Oh yeah.
But of course, yeah.
But I mean, an AI is kind of cheating. You know what I mean?
Course,
Like you got too much help.
Yeah, that's true. Oh,
Now with machine learning, bro.
Yeah.
The amount of shit these people are pulling.
Yeah.
The other day,
algorithms are really getting really complicated.
Bro, the other day I was reading an article that said that passwords as we know them will only be good for us until the first quantum computer gets fucking
anything will be
released.
useless for us once quantum computing. I think you understand that like binary is for every scale of binary is one of two, right? We know they're trying to standardize. Right now, there's at least 150 positions that one unit can be. So if you have one unit of memory, you have one bit. This is a 0, 1.
Yeah.
Quantum right now, as a standard, there's no standardization, but if they were to finalize it right now, it would be 150. You're talking about 2 to the power of whatever 150 is, and that's one unit. Your thing does 2.37 billions of that a second. Now multiply that by 75.
It's limitless. It's basically infinite.
So when they say technology is logarithmic, is exponential, they mean logarithmic, which is also like COVID's really hard to track too, because so is COVID.
Fuck yeah.
Because one person infects 100. Every 100 person affects 100. It's logarithmic. It's only exponential.
Yeah. It only goes up.
Yeah.
So either everybody gets it or everybody dies.
My 6th grade math teacher said this to me, and I love it when you remember something from childhood because he said it perfectly. He's like, for 10,000 years, the fastest internet was a guy on a horse. And then we made the internet. And then when we made the internet, it took us 60 years from flight to go to the moon. 60 years. It took 10,000 years for us to learn to build pyramids and get off of a horse. And he's like, when he means exponential, he's like,
there's no stopping it now.
He's like, you don't understand the scope of exponential, like the scale of exponential. Like it's literally like scales. And when he said that, I was like, 60 years, 10,000 years, pyramids, internet, the moon. I was like, oh yeah, no.
Yeah.
Bro, in 100 years, this year, they cured the first person of diabetes. I think this year, the second or the third person is cured of HIV. Once we can grow hearts, I think heart failure is the #1 cause of death in the first world. I mean, once you can grow a heart from anything, I mean, not that we need more white people in the world, but yeah, man, once we can grow organs and once we can have quantum computing, there's no reason to stay here. Like
we will technically be able to live to the fullest in a ship.
We
already have technology that recycles oxygen.
Well, here's the one problem is energy, because the planet gives off so there's a scale. I watch Star Trek a lot. I used to watch So I forget what the scale is, but there's a specific word for it, and it's the amount of energy that a species can harness. We are a zero civilization, which means that even now we cannot extract the full energy of our planet yet to use to harness, right? Yeah. A scale 1 universe can use the whole planet. A scale 2 can use multiple planets. I think a scale 3 can harness the sun, which is like what the Dyson Sphere project is.
Yeah.
And then 4 is a galaxy, and then Civ 5 doesn't exist, but we would assume that they would be able to harness entire realities, like galaxies and dimensions. So the reason we can have nuclear fission, the Chinese have a stable fission, a cold fusion device.
Yeah.
But it lasted 30 seconds, and it took way more energy to make that fission stable for 30 seconds it is coming out. But if we can make fission the way the sun does, meaning if we can have something so powerful that the gravity keeps the energy back, but the energy pushes out the gravity and it's equal, that's equilibrium. That's infinite energy. That's what cold fusion is. That's what we're trying to get to. Because unlike coal and natural gas or whatever,
that famous perpetual energy that every cartoon when we were kids was talking about.
And even if you're at 99% efficiency, it's still way better than what we are now. Even at 90s or 80% efficiency. Hell, I think even nuclear power right now is at 20 or 30. It's not even close to what cold fission would be. But yeah, once quantum computing, once we can grow organs to heal people, and then once we can get energy, those are the 3 limiting factors of existence in reality.
Yeah. And let's not even talk about the whole Neuralink situation, because that's going to be huge. You know the project that Elon Musk is working on, Neuralink.
Oh, I see. Like fusing AI with brains. Yeah.
Bro, like I watch a clip of him
Installing
saying
it into
saying like he was asked like was the limit, like to what point
Yeah.
can we benefit from this?
Yeah.
And he's just like, he stops for a second and he's like, we're not even we're not gonna have to talk. We're not gonna talk anymore. Language is gonna die because we apparently what they see as not even like the most incredible thing that could do, but
Right.
apparently that's what they are seeing as possible with it. We will be able to transfer concept to one another. So like you think something and you will just communicate it to me in a split second. I will know what you want, what you're trying to say, what you need. There's no more like lying is going to be hard. You know
That's
what I
true,
mean?
yeah.
Like as a society, that kind of device, you know, and I'll put it up there, bro.
Yeah.
I'll put it with quantum computers and
Well, here's the
cold
thing with
fusion.
that. So there's two questions. I feel like that question is easily derived into two questions. So what can a computer do best, and what can a human do best? So computer, we've already known that. A computer calculates. Do you know what a computer is? Like, do you know what a processor is?
Yeah.
What is it? Like, what does it do?
Well, it basically, damn, you actually got me up.
A lot of people, and it's funny because
I know what it
all
is,
my
but it's hard to
friends-
put it on words.
Yeah. All my friends, like, I'm a gamer. I'm like whatever, and like I didn't realize I didn't know what a processor was until like I was like 22, 23, because someone told me. I was like, oh, that makes sense.
Well, you're gonna correct me here.
Yeah.
I'm not afraid of sound. Yeah, I'm not afraid of sounding dumb.
Like an idiot too. I was
Yeah,
like,
yeah.
It's a process. It does math. Okay, yeah, but what? Like how?
All right,
Like,
so it uses
I don't know.
binary code
Right.
to solve well, not problems, to do
Calculations.
calculations.
Right.
So using binary code and solving calculations,
Right.
you can
So that's what
program.
that's what it does. That's what it does. But
yeah.
what is a process? Like when you bought your
Whatever,
you
yeah.
got, what is it? What is that? When you look at that chip, what is it? What is it? Like literally. what
like
is it? What is
how is it working?
Yeah. If you had a magnifying glass right now, what is it?
It's just a fucking bunch of transistors. I don't know, bro.
Yeah.
Transistors. I don't know. Yeah,
okay,
it's a good
alright,
question.
So here's the thing. Okay, so it is.
I'm gonna fuck some people up with this.
Yeah. So it's transistors that are so finely cut, and that's why they're hard to make. The silicon based, because they're the difference between them is like 7 micrometers, 7 whatever. But basically, you run a charge through it, and either there's a charge or there's not a charge, right? So it's on or off. Now we use binary zeros and ones to make it easy for us, but you can say left blue or
Yeah,
red. Or
you need
doesn't matter,
two. You
whatever.
need two
Yeah,
things.
Yeah, it's got to be opposites, right?
Yeah.
So these transistors, a pair of them make what's called a logic gate. And a logic gate can be on or off. So basically if one is on, one is on, and then that is what pops out that 0 or 1. And that's all it is two transistors making a logic gate, and that's what true and false is in math. If or, you know what I mean? Like if this, then that.
Yeah,
so
yeah,
if
yeah,
this logic gate is on, the next one will be off. If this is off, if both of them are on, and that's all it is.
And
It's
you
a
just
bunch-
put
it's a
it
bunch
on top of each
finely-
other to infinity.
And they're just so cut together, and they're so clamped up in such ways, and the way you put it is called architecture, which is why you would see programs called x86, x64, x32. That's called a bus scheme. That's how, like, whatever. But that's getting into it. But that's all it is. It's literally two things that you either charge to, and it's either on or off. And that's what a processor is. That's all it is. There's no magic to it. You and I, if you get like a Raspberry Pi, a computer all in one chip.
Yeah.
That's all it is basically just add math. Like do this and do that. And the computer doesn't know it's doing math. You're just telling it, listen, if you have an integer and you have this integer, these two integers make this integer. And the computer just does that. Why? It doesn't know what it means to a video game for when it does a 3D graphic. It doesn't care. It doesn't whatever.
That's its purpose.
That's its purpose, is on or off. That's its entire purpose. So for the Neuralink thing, I think would be the better question would be two things: is what does a computer do best, and what does a human do best? Now, a computer this calculation's best. We are at a point where our math right now, our computers are doing 80% of the math because we can't even.
It's
they're doing it
bottleneck.
at such a high order
Yeah.
that we're randomly shooting. This is getting to like superstring theory and like gravity and whatnot, but it's so immense that we're just using terabytes of 10 to the 10 to the 10 to the 10 to the like it's so many calculations, but you turn that thing off and it's off. There's no such thing as AI. You can't. There's no self-preservation. It's not life. It doesn't care to be alive or to do it. And it doesn't care that it's not doing it. It's just a piece of metal that electricity is going
like
through.
a hammer.
Exactly.
It's like a
It's
hammer.
literally a hammer. It's a really complicated hammer, right?
Yeah.
And then I guess the other question would be, well, what does a human do best? Well, a human...
Decision making.
Exactly. So we have judgment, we have concept, we have intelligence, and more importantly, we're biological, meaning that unlike viruses, we're self-sufficient. We don't need others to... I mean, we do have to reproduce asexually or sexually, but fungi can do that, you know, right?
Yeah.
But we are intelligent. We can domesticate. We can make judgments. When I tell you, I put Nat in a box, but the thing is too heavy. If I tell a computer that, I can tell the smartest computer that sentence, and it won't know if I'm talking if Nat's too heavy or if the box is too heavy.
Correct.
But you'll know that Nat in the box is heavy because Nat is most of the weight of the box. A computer can't figure that out.
Yeah.
Just like when you see the "Are you a robot?" which is a bicycle. You can feed it photos of a bicycle until it can kind of see how the shape of a bicycle. But I have to show you 3 photos of a bicycle, and you'll know every bicycle made ever.
Right
if
away.
It's in a junkyard, if it's broken, if it isn't assembled yet, if it's in a box. So we have a judgment thing.
If it's on a New York City post with both of its wheels stolen by someone.
Exactly. Yeah,
If it's an
exactly.
abandoned bike.
Chained up to the weirdest.
Yeah, you will know.
A computer can't deduce these things. A computer can only do math. So I guess a Neuralink, yeah, you'd be able to. Well, I want to figure out. You know what you could do? You could do what Neo does. I think that a Neuralink would be able to make a human dodge a bullet, because you'd be able to calculate projectiles as faster than they are happening. That's something that's possible.
Well,
Transferring concepts, I don't know about that, because I feel like transferring...
will your body allow you to? Can you fall, like, can gravity pull you down faster than what the bullet is going to travel?
Let me rephrase. You won't move faster than the bullet. But you, if I'm shooting you and I don't have a Neuralink and you do, you, just by kind of gazing where that barrel is, would be able to pre-adjust and maximize your chance of survival and graze yourself, as opposed to somebody who's just guessing, like a soccer. Actually, that's a perfect example. Soccer.
Yeah.
Like
they're just guessing.
Ball keeping if you had a computer angle, because here's the thing: every moment that's passing, you can't calculate that fast as the ball's moving.
A computer will be able to see what muscles you're moving to determine what are you going to shoot,
a computer
left
would
or
be
right.
able to watch 1 billion videos of you kicking a ball and how you move. If you're sick, if you have a fever, if
your wife broke up with you, if your kid is mad.
Hold your left and you realize that you're 10% more on your right leg, which little thing, Usain Bolt is the first Olympic runner to have scoliosis. He stays on his left leg longer than his right leg. When it goes against every running thing ever. When he won the Olympics, it blew everybody's mind because every trainer says you have to have a straight gait. And I learned that when he won the Olympics. He has scoliosis. He stays 20% more on his left foot than his right foot. And it was. Do
me a favor. Keep talking, because I need a lighter. I'll go get one.
But yeah, so you'd be able to maximize your chances of saving a goal, like when someone kicks it, maximizing your chance of dodging a bullet. Sure, once the bullet is fired, your body has limitations. You can't, it's a piece of metal being fired. Like the kinetic energy is insane. But if the shooter didn't have it and you did, you would graze. You'd be fast enough that you wouldn't die on the spot the way as if you didn't have it.
Yo, that's fucking ridiculous. Mm-hmm. When I think about it, I wasn't aware that he had that going on.
No. Yeah, take your time.
All right.
Sorry.
Damn, there's no way of fucking being ready with everything. I'm gonna have to write shit down, bro.
Yeah. No, literally, that's yeah.
Yeah, I'm gonna make a list.
There's a thing called dress rehearsals. We do them in theaters, and it's specifically you write shit down. You're just like, oh right, yeah, I gotta put a shirt.
We do it in theater.
Yeah, I used to do theater.
You where? What are you talking about? I know. I don't know about this.
So it's funny because I played instruments too. I was so like in elementary school and shit. I did theater and I subconsciously I didn't know why I chose theater.
Yep.
Because they would separate us in groups and be like, well, what do you want to do? There's like a math club, theater club, and whatever. So everyone chose. I was one of the last kids in class because I was the tallest. You usually do it in line order. And I went to theater, and I was like maybe one or two guys that was there, and it didn't click until I saw Heath Ledger's Joker's the Christopher Nolan series Batman.
Yeah.
And Michael Caine had an interview because he's Alfred.
Yeah.
And he will always be Alfred. I'm sorry. That's
Alfred. I agree.
Michael Caine is Alfred. If I could have an infinite amount of money and I needed it, I would need to AI Alfred the way Michael Caine
he can
looked
be
at 60.
on every movie.
He is
till eternity.
Like literally, I watched Batman the animated series and that Butler. I see him as Michael Caine. That's Michael Caine. I don't care.
I agree. No, I agree.
Yeah.
And you know what? We're gonna have the same problem with Iron Man.
Oh yeah, Robert Downey Jr. Yeah,
he is Iron Man.
Yeah,
so they can't bring him up again. Yeah. Even on animated shows and video games.
Yeah. He needs.
They are making.
He has to have that quick that. Robert does this thing and she's like.
Yeah.
He has to have that type of like. I don't know where that accent's from. Actually, I don't know where he grew up. I don't know anything about Robert other than he.
I have no idea.
Other than that drug addiction he had in the 20s.
Motherfucker.
Yeah.
I'm gonna Google this shit, bro.
I don't know anything about Robert there, and he was, he was that music video.
Where you from, dude?
Yeah, where's Robert?
Like, I love you, and I don't know anything about you.
American actor, blah 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 blah.
Oh, his born where? Early life. Oh, he's a New Yorker.
Of course, he's a New Yorker.
He's a fucking New Yorker.
Nothing makes me happier than every successful person, and they're like, and I'll even take credit if you're in like. Westchester or like because J-Lo's from Bronxville, like she's not even technically from the city, like,
yeah.
But like I'll take credit or like Nassau County or Long Island, like because every Jewish comedian's from like Nassau or like the Hamptons, like whatever. I'm just like, okay, I'll take that. That's still New York.
Well, this is gonna sound a little bit controversial, but even if somebody's from Jersey,
yeah,
if they hanged out in New York,
yeah, if you're in Northern Jersey, you're spending most of your time in New York. There's nothing to do other than being. Close to New York.
Don't say that.
Other than being in the city. And if you're in Southern Jersey, fuck you, and I hate the Eagles. Philly can go fuck itself. Kidding. Philly's a beautiful city. I'm just I'm a hard Giants fan, and it's unfortunate because it's not a good. Although a couple friends of mine are Jets fans, and that's just depressing. I can't imagine.
Bro,
yeah,
what's the name? What's the name of the hockey team?
Of
your hockey team.
Oh, the Rangers.
Rangers?
Yeah, Rangers. Yeah.
The other
Rangers,
day,
the
other day, I was walking up
Liberties.
8th Avenue, and there was a game. There was a hockey game,
Yeah.
and I saw so many people coming out with their jerseys,
Rangers,
and I was like,
it's New Jersey Devils and New York Rangers. Yeah.
Rangers.
Yeah, we have not won, and it's sad. It's not a great. And you know what's even more depressing? 2 years ago, Las Vegas opened up their first NHL team, the Golden Knights, and they made it all the way to the playoffs. They lost at the last game for the championship, their premier championship. Bro,
that would have been a movie worth.
The New York Times calculated because it was 40-1. They calculated that like $800 million would have been lost by bookies. If the Golden Knights won, like it was insane, like a schmajillion load, and all the bookies they were like interviewing the big bookies, the small bookies, like the big casinos, the whatever, and all the managers were just like, he's like in 60 years I've been like dealing with sports betting and whatnot, and he's like I've never been more conflicted because it's my home team, but also I'm gonna lose my entire business if they win.
Yeah. You know what? I actually something similar happened to a friend of mine. He lives in Tampa, and he works at a betting club, a sports betting club, and you know how everybody in Tampa loves Tom Brady.
Yeah.
And by the way, I don't watch football, but the fact that someone will get out of a team because they basically don't want to pay him or give him the benefits that he deserves, he fucking rightfully deserves, right? And goes to another team and then fucking wins the Super Bowl. And this year they're the favorite team, bro. I gotta get back that shit. You know what I mean?
Bro,
it's the most badass fucking thing ever. Yeah.
No? Okay.
Yeah. Okay. All right.
And then fuck your mom. Like, he fucks your mom like the next day. That's literally.
So my friend, I visited Tampa around that time, and they were playing, and I was like, bro, how's Tom Brady playing? And he's like, oh, that motherfucker. And I was like, what are you talking about,
Oh,
bro?
yeah, because he's
he's like, bro, everybody
The
comes here,
Buccaneers.
they bet to the Buccaneers, and when they win, we're losing money, bro. And I was like, fuck, you're right.
And he's the face of football. He's the.
Bro, it's incredible. There's people in Boston that even, they're cheering for him on the Buccaneers. There's a lot. Like,
There's a difference, though, because Tom Brady. I mean, you have really good quarterbacks, but Tom Brady is NFL. Whereas, like, even in Premier Soccer, like, yeah, you have El Nino, yeah, you have Ronaldo, yeah, but you have 5 or 6. There's like 6. No one's like other than Pele, who's now whatever, which would be the only figure. But like, you can have at least 4 or 5 to choose from. In the NFL, there's the best quarterback ever. There's no one brings up Heisman, no one brings up Tom Matt, like it's Tom Brady. Like Tom Brady is football.
Exactly. He represents it, and I don't know. Maybe I'm just thinking with my heart. Madden
just died like 3 or 4 days ago.
Oh yeah, he
Madden
did.
died,
Yeah. I know about this.
Yeah.
And I'm not ashamed of saying it. But before he died, I didn't really know who he was. I knew.
No one knows who Heisman was either. Yeah.
I knew that the game is called Madden. But I didn't know that it was called Madden because that was the last name of someone.
Yeah.
I had no idea. And then he died, and when I recognized the last name right away, and I was like, "Fuck, who is this guy?" And
he made all video games. Fuck, the guy who makes the video games died.
Yeah, I was like, "Fuck."
You know, it'd be funny, like if a Gen Zer, like if Michael Jordan died, they'd be like, "The sneaker dude that made the sneakers, he's dead."
You can be 100% sure that will happen.
Oh yeah, 100%. He played basketball.
and this is gonna be a little bit of a sexist comment, and I'm sorry for whoever gets offended by it, but that's most likely gonna be said by a girl.
Well, it's 2022. What's your definition of a girl? I can be sexist, but
some Bronx chick out there with her big ass nails, she's gonna and her big ass eyelids, and she's gonna be like, the sneaker dude. You know how they. Going back to your theater situation.
So here's the thing. So I watched I watched his interview with Michael Caine, and they're like, "So what got you into theater anyway?" Because he was a great mathematician. I don't know. He was like very good at, and generally men in the UK in the 30s and 40s generally tried to be engineers because this is post World War II. They had to build up factories and shit. Europe was devastated. And he goes, in his accent, it was all the women were in the theater class. And so I went there. And I was like, that's why I chose theater when I was a kid. I was the only dude. And worst case scenario would be one of 3 guys. And I was like, subconsciously I didn't know that. But the words came out of his mouth. And I was like, that's why I fucking did theater.
And they were probably gay.
Well,
like,
exactly.
Don't get me wrong. Don't get me wrong.
Yeah.
I fucking love gay people. I don't want anybody.
No, of course.
to fucking
one
date.
was. Well, and we knew when we were 5, we knew he was gay. No one cared. He's still a friend today. Yeah.
That was here though.
Yeah.
Where I grew up.
Oh, that's true. You don't have to.
It's different,
that.
bro.
And I live in New York City,
no kid was gay when I was.
Gotcha.
I mean, they were obviously, but they were in the closet.
Yeah, exactly.
Which is not fine, but it's fine in the way that I don't mind.
The way society was.
Yeah, exactly.
Yeah, no one's. There's no Spanish Inquisition. No one's turning him into the cops.
Yeah,
like, he's not going to jail.
Yeah. He's not getting killed like in Russia.
Yeah, exactly.
I love Russians, but they kill gay people, man. That's not cool.
Bro, they kill everybody every time. You want to be running for office, and it don't even kill you. What's that? It's not cyanide. It's that uranium-246, like that specific isotope. And they're doing it everywhere. They killed 2 guys in Germany, 2 guys in the UK.
Is that the one they put on the needle?
No, it's just powder. It's literally just uranium. It's
So what? They
uranium
just put it on your face?
Put it anywhere. As long as it touches your body or it gets inside your body, you're dead.
You kidding me?
Bro, it's fission material. It's radiation. You will die.
Does it make and it makes no
Well,
smell?
Well, no, other than radiation, you'd have to get a
but
Geiger counter. But no one's gonna be like, oh, no one's gonna go. He's sick in the hospital. Let's go get the Geiger counter. No,
Yeah.
you're gonna run blood tests.
Correct. The
no
last thing
infection,
anybody will
yeah,
try
exactly,
to look for. Yeah.
And then after all the tests are done and all the negatives, then you realize, hey, are you a politician in Russia? And then they get out the Geiger counter and they're like, oh, he's radioactive. Okay.
Oh fuck, man.
And the thing about radiation is the reason it's so dangerous is because the half-life, basically how long the atom survives by itself, is thousands of years, hundreds of thousands. Like even spent uranium rods, once we finish with those fuel rods, we put them deep in the mountains, like because they will live forever. They will last. They will be radioactive for thousands. Tens of thousands
what you're telling me, and I'm gonna ask it, like
yeah.
if I was a 5-year-old kid, obviously, because I don't know. What you're telling me is that the isotopes, they use them for a bit, and then they're not useful anymore. However, they're still radioactive.
Yeah. So
how does that work?
So atoms, there's two ways atoms has energy, right? One is mass, which is how much stuff is in the atom, which is the nucleus. It's like the protons and the neutrons, right? And that's the mass. And then you have that electron. That electron has what you and I would call energy, like electricity, heat, whatever. That's 99% is in that thing. But 99% of the mass of how much stuff is in it is in that nucleus. The bigger the nucleus, the more dangerous that fucking thing is when it zooms past us. So like light.
Yeah.
Right. Okay. So uranium, if you look at a periodic chart, is all the way in the 200s. As in oxygen and hydrogen, which are in the 1, 2, 3, 4, 5, 6. Uranium, plutonium, all these really long names, they're at the bottom of the list. Their atomic
all
mass.
These names.
Yeah, exactly. All
the last name
Yeah, exactly. They're all the way at the bottom because they are 100, 200 times more dense than oxygen, hydrogen, whatever. And so that's what makes it so dangerous, because when one of those things shoots through an air, it will pulverize your skin. Any organic material will rip through like a bullet through paper. That's exactly the
absolutely.
thing. Yeah. So, and because all things decay, that's the law of entropy.
Time out. Can you tell me more about that law before you go?
Law of entropy? Yeah. So basically, when the Big Bang happened, not to get too complicated. So the existence of everything, when the Big Bang happened, basically it was nothing, and then a lot of energy was spread out across even more things. So let's say that this table is the entire universe.
Correct.
And the only energy we have is what's on the table. This iPad, the keys, the whatever. Now, the scale isn't really great, but they're very far apart. And there's just specks, very, very small. So what happens is billions and billions and billions of years, while these things are randomly floating, eventually, mathematically, 2 will hit. And then a third one will clump. And then a fourth one. And then a fifth one. And a sixth one. And a seventh one. And then you get these planetoids. So you can get like these water comets, you can get these whatever. And so once they get enough mass, you get gravity. So things start falling toward it.
So it gets bigger.
And it gets bigger and it gets bigger. And mind you, the scale of this time is not minutes. It's millions, billions of years. I mean, you couldn't understand the scope of these things.
Yeah, it took time. It took time.
So once you have these things with gravity, you start to have the circular motion. Angular momentum is something that's complicated. We won't get into it. That's for all you physics professors. Guys going to college doing STEM, I'm so sorry for you guys, but angular momentum is terrible. So it works exactly the way like a blender does. So like when you blend something, all the heavy stuff gets really close, and all the light stuff, like in a drink, floats on the top, right?
Yeah.
Same thing in space. The more mass you have, the more the attraction is to other mass, and that's what gravity is. When two forces of gravity have different mass, they get into each other really, really close. And so that's how rings are made in planets.
Yeah.
People are like, oh, God had to make these things. I'm not saying that this proves that God doesn't exist, but there's a reason why God doesn't have to exist, and it still happens, and it's exactly like a blender. The thinner things stay on one layer, the heavier things are on another layer, the thicker things aren't, and then if you're thick enough, you smash into the object, and you become the object, right?
Correct.
So you start smashing these things, and then just the heat of these things will start to rise the heat of this planetoid. So then it becomes hot. What happens when things get hot? They get ignited.
Yeah.
And that's what infrared is. Infrared is heat. It's just how fast an atom is moving. And that's why when you have IR goggles, or you can see, the reason you can see a fire in the night is because the fire has more energy than the cold air around it. That's why you can actually see it. And if you look at a fire through infrared scopes or night vision, it picks up that fire easier than the cold. And it's because it's the same way light works. Blue, red, green, it's just because they have different wavelengths, right?
Correct.
And so these things, when they come together, they get really hot. They bring in more things. And so, like I said, everything's logarithmic. In the beginning, no planets formed in the Big Bang. Nothing. I mean, you had like clumps of planets. Earth at some point was the size of a fist, or the size of one molecule, the size of even a subatomic particle, I'm sure. We're just learning about that now. But then it got really, really hot. And then, once it got hot enough, it would turn into these things called stars. And these stars would have so much energy that really they should be exploding. But because they have so much energy, the gravity of the mass
own
is
energy
holding the explosion back, while the explosion is so powerful that it's blowing whatever. And when you have that perfect balance, that's why the sun is stable. That's why it's not blowing up on us, and that's why it's not sucking in. Now here's the thing. Because of the law of entropy, all energy dissipates. Everything dissipates. When you build stuff up, eventually it will come down. When you bring heat, eventually that heat will burn out its fuel and will spread.
Everything is transforming at all times.
Everything is yes and no. So it's the same way the wind happens. Wind happens because it's air traveling from high pressure to low pressure. Is there a reason for it? That's the law of whatever. Water is attracted to solids. If you put a drop of water on a piece of paper, it won't stay against a piece of paper. It'll get in that piece of paper and it'll soak.
Spread.
Yeah. That's just how, I'm sure that there's a mathematics. I don't know what the formula is, but that's just how it exists. That's what it works.
Correct.
So it's the same thing as the law of entropy. When heat, it will disperse. So eventually, because the sun's getting so hot, it became so big that other planets that were not as big start to revolve around it. And that's why you have orbits, because the Earth and the sun are pulling at each other at exactly the same energy as they are pushing it away. Mm-hmm. And that's what orbit is. Orbit is literally the rotational momentum of, it's actually just going forwards and backwards, but it's falling sideways. And that's what the space station does around the. People always say, well, how are you not in gravity? It's not that there's no gravity. It's that gravity is perfectly equal, and so you're going sideways.
And they use thrusters, right?
So, well, those thrusters are because the Earth is not perfectly spherical.
Correct.
It's spinning.
So they correct it, because
they
otherwise they will get closer and closer and closer.
Or
worse, farther and
which
farther.
Is the problem,
farther.
right?
Yeah.
Because then you can never get them back. Yeah, that's the problem.
So they use thrusters
eventually,
to correct.
Right.
Yeah.
And so just because in real life, obviously, you have the model of the atom or the model of the Earth, and it's a perfect globe. And in reality, the Earth is spinning. It's actually squeezed in a little bit in the middle, and it juts out a little bit. And not only that, the Earth is not spinning on a perfect axis.
It's a little bit
exactly.
tilt. Yeah.
So you know exactly. Right. Exactly. So just because of these other laws, basically, so what happens is eventually, the gravity will not be enough for the energy that the sun is holding to hold it back.
Yeah, to withstand.
So what we call these now there are different stars. There's called red dwarfs. There's white stars. There's depending on how much energy is an actual star. So what will happen is that because of the law of entropy, the sun is running out of energy, and at a certain point, that gravity will be weak enough where the energy will overtake the gravity and it will explode.
Is it running out of energy, or is it running out of hydrogen, which is its fuel?
Well, it's not that hydrogen is its fuel. So in the sun, there's lots of atoms.
Correct.
The core of there's four naturally occurring states of matter. 3 you see a lot of.
Yeah.
Liquid, solid, gas.
And then you got plasma.
Gas has the least, solid has the most mass or energy, generally speaking.
Yeah.
Plasma you see sometimes. There's 19 states of matter. The problem is you don't see them.
Excuse me, did you just say 19?
That we know of.
What?
16 of them we can observe in natural environments. 3 of them we made in a lab just to see if it can work. So the Sun's core is
Is that a topic for another podcast?
Yeah.
Okay.
So the Earth's core, and it may not be the Earth's core, but there is places in the universe that matter has so much energy and so much mass that it's a solid, liquid, gas, and plasma all at once. If you touch it, if you try and punch it, assuming you don't evaporate immediately, it'll be solid. But at the same time, it'll move. At the same time, it'll evaporate. And at the same time, it'll be electrical. All at the same time because it has so much energy. It does all of the things all the time. And that's what's happening at the core of the sun. It's not solid, it's liquidy, it's magma. We only see the corona. Like when you see the sun and you see those molten whatever,
Yeah.
that's just the top. That's like what the Earth's core is magma and complete. That's the surface of the sun. So our hottest thing on our planet is the coldest thing on the sun that powers us. Can you imagine what's inside the sun? It's like this crazy material that acts as a plasma solid. It's all this states.
Do
of
we
matter
know
all
what
at
it
the
is,
same time.
or we can
they
just
have names.
theorize?
No, we've made stronger ones in a lab, but the thing is, they're one atom big. Yeah. You literally need a microscope to
see it.
Yeah, the sun is you can fit 100. How many? Like 1,000 Earths in the sun.
Correct.
We can make cold fission, but that cold fission is like in CERN. We make nuclear explosions all the time in CERN. At CERN, at LIGO, not LIGO, at CERN, what they do is they'll take isotopes of, I think, hydrogen, and they will shoot hydrogen at each other. The problem is they can't, because of quantum mechanics, there's only percentages that you can theorize. So you can get like 40% chance, 20% chance, 10% chance of hitting each other. So what they do is they shoot a lot of them at once. And it only happens one every couple of hours, one every couple of minutes, that 2 of them hit and then blow up and they split, and then you can see the subatomic particles, which are like the boson, all these like Norse names that these scientists name after each other, whatever.
Yeah.
And so that's how we found out about dark matter. That's how we found about antimatter. So we have electrons. There's a thing that's opposite of that called a positron. We can't see that. That's in dark matter. Like dark matter, we can't see. In fact, black holes, we can't see. The only reason we knew that black holes existed was because Albert Einstein theorized that a sun could get so powerful and have so much mass that I told you it was perfect equilibrium. This sun is going to have more energy than gravity.
Correct.
The sun right now has an equal amount of gravity and energy. There's a thing that is so dense, so powerful, that there's only gravity and no energy. It has so much energy, so much gravity, that it doesn't matter how much energy you put into it. You can throw suns at it. And the gravity is so nearly infinite. It's 0.999999999999999. Light cannot escape this. We call these black holes, and we didn't confirm them really until a telescope. And technically, we didn't really confirm it when we had the Hubble telescope when we launched it in the 60s and the 50s. We didn't confirm it because we can't see the fucking thing because it absorbs light. What we can confirm is we see these suns disappearing in this spot, and you're like, what the fuck is there? And so based on Albert Einstein's math, we're like, oh, this must be a black hole. Now, technically, it's still a theory because no one's ever put their hand in it.
Correct.
But they're 99.9% sure that a black hole exists.
And now that you mentioned that, I read an article this year about how scientists, for the first time ever, saw light actually escaping a black hole.
So that's what quantum theory is. It's not light. So Stephen Hawking, who recently passed away, God bless his soul.
Yeah.
We very rarely do we have scientists that change everything. First was Isaac Newton, when that apple fell onto his head and he realized that gravity is a thing.
Correct.
That momentum is a thing. That every action has an equal and opposite reaction. Then you have Albert Einstein, who is like, hey, and Oppenheimer, it was like, hey, we have these atoms that if you smash them together, you can destroy Japan. And then there's these black holes, and the E equals MC squared, which was the truth, and it's 99% correct, but it's not really real anymore. It's not considered. It's just easier to teach kids E equals MC squared if you're not in the.
And we also gotta be honest. When people say E equals MC squared, 99.99999% of people don't know what
that is. Anyway, right. But in reality, that actually doesn't exist anymore either. That's been disproven by Stephen Hawking. Stephen Hawking theorized that there's no such thing as a non-finite space, because until then, Albert Einstein was like, well, nothing's faster than the speed of light, and there's a black hole, and black holes suck up all light. So there's this spot in a galaxy in our existence where technically it's not a space. So how can you have not a space in a place where there's space? Obviously, something's happening. So Stephen Hawking decided to do some more math, and then during one of the scans of a black hole, he realized that during quantum mechanics there's these pairs of molecules. And depending on, well, actually, this is the rule of all quantum mechanics, is if you look at an electron in an atom, the law of perspective applies. When you look at an electron, it changes position. That's why when you see a model of an electron, you never know where it is. Yeah. There's actually an interesting video for the first time of a real, because people see atoms in two ways. That ball with a circle around it, and then that flat one with the whatever. But it's neither of those. It's actually a ball and a big rain cloud.
Is it long? Do you want me to play it?
Oh yeah, play it. Yeah. So YouTube, what an atom really looks like.
All right. So
bring it up, Jamie.
Yeah.
What atoms?
I'll be happily Jamie on this one. What an
Yep.
Thanks to Google for sponsoring a
So just go.
Give me a second. And sorry for anybody watching.
Yeah. We'll edit. We'll post in post-production.
Yeah. In post-production.
Yeah. We'll splice these things together.
Yeah. Fuck.
Record screen. No?
You know what? Fuck it.
Portion of this video for supporting small businesses
and
for helping people find jobs. More about all that improvement, but they're still very much more technically inspired. Yeah. But none of which feel like they give me a sense of what's actually going on. Like, what does this blobby thing have to do with orbiting electrons? Is I things sure out and some are closer in.
More.
It's in them because they're going mechanic scale, lack of dust, and.
There we go. So go back. So start around here.
Mentions. Here's what you get.
Start around here.
But there is a way of thinking about
just a little bit more, just a little back more.
Picture the wave function as a bunch of. But there is a way of thinking about wave-particle duality where you picture the wave function as a bunch of water and the particle as a speck of dust in that water. The particle is mostly guided by where the water goes, and the water is guided by the equations that determine how water behaves depending on its circumstances. And if you apply the mathematics of that idea to atomic orbitals and then render it in 3 dimensions, here's what you get.
That's what an atom really looks like.
Wow.
Isn't that beautiful? Here's another.
These are all isotopes of hydrogens. This is just hydrogen, and it's different. This is just one atom.
Oh my goodness!
Another.
They don't teach us this, and I don't know why they don't teach this.
Well, I mean, come on, bro. This guy had to do this video for a reason.
In fact, I made a bunch of these, and they're all mesmerizing and beautiful. And isn't the ground state of the hydrogen atom just so cute? And aren't the excited states?
Wait, time out. If this is how they look like, when they say that we humans split the atom,
Yeah.
what did we split? Did we literally cut this in half?
So when we say split, it's just easier. It's once the nucleus. So this is the nucleus where
Correct.
the protons and the neutrons exist.
Correct.
Once that's fractured, at any scale, it has destroyed the whole thing. Everything
Collapses.
holding it together. Yeah, just whatever.
Yeah.
So we're not the way like a cookie.
Yeah,
whatever.
it's not
But
a
yeah,
split.
once two nucleuses hit each other at such a speed that one fractures, that has been destroyed.
Yeah, by the way, for anybody listening that doesn't know how atoms work, the electrons in it actually are, even though they're all compartmentalized and together, or, well, not together, but they're close, very close to each other,
Yeah.
they're traveling at speeds that are very close to fucking light speed. Like this.
So it's not. It's funny because technically that's the easiest way of saying, but in reality,
You know, I'm putting it on layman's term.
yeah.
I'm a layman, all right?
Yeah. So they're traveling. The easier way to say it is they're traveling at a speed that is not a speed that they're technically, depending on where you look at them, there are at multiple places at multiple times. It's not that they're traveling. They are at a quantum state.
They're just here and there.
Yes,
And
they
then
are
there.
here and there and there, and that's what all these reactions. It's not that at a certain time it's here and it's there. It's that it's at all of these. That's how much energy is in an electron.
But this is matter.
This is
Like matter is this
is the
a
most
bunch of
base-
this put in together.
This is the smallest unit of matter that you can have. You cannot get any smaller than this. Anything
As
smaller
of
than-
right now.
No. If it's a molecule, if it's an atom, we can cut that into subatomic particles. Boson particles are subatomic particles, but it is no longer a thing. Like boson is not hydrogen. When you have hydrogen, you can put hydrogen in a gas tank. You can't put boson particles in a gas tank.
Correct.
That doesn't. These atoms don't. These atoms have characteristics.
Yeah.
When you put that and next to a fire, it'll blow up. Boson particles do not have characteristics of matter.
Yeah.
So the
Yeah,
smallest,
they don't behave
Exactly,
like
right.
regular matter.
Exactly.
You can contain them. You can shape them.
They don't work exactly.
Yeah.
So this is one singular piece of matter. Literally, it's one unit of matter. Can't get any smaller than that. Now the size of that matter.
This is the one in the binary code.
Yeah, this is exactly. Anything smaller than that, and you're talking about the metals and the transfusion, the electricity. It has nothing to do with binary anymore.
Yeah, you're talking
It's
about
just-
light.
You're talking about gravity. Yeah, you're talking about dark matter. You're talking about and right now, due to meta superstrings theory, it seems like we don't live in a 3D world. It seems like we live in an 11 dimension world, not a 3-dimensional world.
That's fucking.
That's the current
That's
thesis.
fucking amazing.
The problem is we can't
Prove
see the other dimensions, which is a problem because then we can't measure what we can't see.
Yeah, actually, now that you mentioned that, and I will play this, but now that you mentioned that, I got a friend. I'm not gonna say that she is an ignorant, but physics is not naive. It's just that out of everything that she's learned, physics is not one of those things that she's focused on learning.
Yeah.
And I was trying to explain stuff to her.
Like, I know jack shit about Shakespeare. I totally understand.
I don't know jack shit of anything.
Yeah,
you know what I mean?
Yeah.
And I was explaining dimensions to her, and I used the fish reference. You know how to fish, the concept of something out of the sea is an alien concept.
Yeah,
They can't
You're
see.
literally in
This
an
is
environment.
this is what they
Outside
can
of
feel.
your environment.
Yeah. Their senses, fish senses is whatever is in there.
Yeah.
Right? Whatever they can see there, they have no idea that something exists out of that realm.
A bird about to pick them up.
In the same way that bacteria doesn't sense or feels what is out of their realm, right?
Exactly,
So they, for all matters and purposes, it's like we didn't exist to them, right?
Exactly, right.
In the same way that other
Not only do we not exist, they literally, even if they wanted to, even if there was one super smart fish out there that because that's how evolution works.
Yeah, yeah.
Slowly but surely, there's that one fish that's like, I can walk on land, and that's how evolution worked.
Octopus.
Yeah, exactly.
That'll be octopus.
So
That's
or
one of the
jellyfish.
stories. Yeah, one of the stories that we're actually going to cover in a bit.
So even if there was that one genius fish, he would have to make a contraption
to get out of the water
to
prove it.
Exactly. Yeah. So even if they wanted, they couldn't. Just like even if we wanted to, it doesn't matter what telescope we actually just launched the James Webb Space Telescope.
I was about to say that.
Bro,
yeah, this year is going to be
released. In 6 months, we're going to get the first real photograph of, and I kid you not, the observable universe. So everything that we could possibly see, you know,
might change this year.
The cosmos, you know, the that photo of the Milky Way and the whatever, and you have that observable universe.
Correct.
Those are mostly diagrams, and they're based on the Hubble because when they launched the Hubble, they did not realize how many galaxies there really were. I mean, it was insane. So, and that was the '60s. Can you imagine? Now we have an entirely new thing that can see as far as literally our dimension allows us to see. We'll be able to see the end of our existence. It's going to be crazy. In 6 months...
It will be amazing. I'm actually very excited for the web. Man.
I didn't start looking into... Because I've been in computer engineering for a while. I've been doing networking and whatever. Bro, I did not realize that the rover uplink, that rotor, that helicopter we just sent to Mars, that uplink... Yep. Guess how fast that uplink you think that is? So if we have...
How fast what?
That uplink is. So like how fast is your internet?
But when you mean how fast, you mean how fast it got there, or how?
No, how fast is your internet when you go to the
my
website?
internet?
Yeah.
Let's say I think it's like 3 gigabytes a second, something like that.
3 gigs, right? So let's say what is it like 600 megabits a second, right? 600 megabits. Let's say 500. So just make it easy. Let's say 500 megabits a second. How long do you think when you put in YouTube.com and you press enter? How fast do you think your computer's talking to the YouTube server and back again?
Milliseconds.
Milliseconds, right? Yeah. Because I was like, how do they get HD photos from Hubble? Like, so I looked it up. Guess how long it takes for us to talk to our rovers in Mars, and guess how fast that speed is. First of all, guess how the length of time, and then guess what the speed is.
I will guess a day to download a picture.
Okay. No, not a picture. Just
video.
Data.
Oh, any data.
Forget
any data.
Yeah, any data. Yeah.
Data.
Yeah. So what's your throughput? Like, so you have 500. Guess what the throughput is?
I'm just gonna downgrade it, and probably I'm wrong, but I'm just gonna say a megabyte a second.
Spot on.
Spot on?
Spot on. It's anywhere between 0.5 and 2 megabytes a second. And mind you, this is through satellite arrays. We can't communicate directly to Mars because of our atmosphere. So the 99% of the networking is the satellites outside of our orbit to Mars, and 90%
it
of
gets
the
there
delay
and from there here
is from the satellite outside of orbit through our clouds and shit. And that's why we have satellites all around the globe and that's why we have data centers all around, because guess what? One cloudy day will change, and I did not know this, will change data transmission from 1 megabyte a second to 0. There are some situations where before we launched the full-scale array, that on bad days, if it was raining on the whole northern hemisphere, you couldn't talk to it. It was impossible.
So you're telling me is that all these 4K pictures that we're getting from Mars and all that shit, it's taking days.
Can you imagine how? And here's the thing, mind you, this is with error correction. This is with CRC. This is with, and your shit has DNS servers. You and I have corrections. You and I have backup. Our networks have backup drives, redundancy servers. You know, if one thing goes down, guess what? There's one Mars. There's one rover. There's no second rover if the thing, God forbid, it runs out of batteries. God forbid any of these things. So when they launch these things, it's 80% science, but it's 20% if that one fucking battery does not turn on. We got to do this whole thing all over again. And the camera on it is worse than the one on your iPhone. It's just that there's no atmosphere. So you get those clear pictures because there's no water vapor. There's no hydrogen. There's no oxygen in the air. There's no hydrogen in there. There's nothing between you and that rock. There's space. And that's why it's so clear. because there's literally nothing between you and our lens. We have to do night shift because there isn't enough light. You have to do whatever. On Mars, the light is directly hitting you from the sun. There's no cloud protecting you. Light is literally coming from that big fucking nuclear reactor, hitting that rock, and then going into your lens. No protection. If your head was out there,
Fried.
you would die. Yeah, you would die. First of all, assuming that you had oxygen and shit, that radiation plate, I mean, you would die. You would get cancer in a couple of weeks, a couple of months.
Mm-hmm.
And that's what we call passive radiation. That's not if you're directly in front of the sun with no orbitals around it, not wearing your shield, not wearing those face plates are black. They look black. They can actually see it, but it's because if you think it's sunny down here, imagine the sun.
All white.
No,
all white. Like
it's literally white.
Yeah,
literally white.
It will be all white.
It's pure power. It's pure power, and hundreds of those things, thousands of those things, turn into pure black. And that's what a black hole is.
Isn't that incredible that we have never been there?
Yeah.
However, using
no, we just crash landed. We just crash landed something onto coronavirus as of last week. Yeah, we got to the sun's corona. NASA launched a probe
inside the sun.
Yeah, we got it. We got into it. Yeah.
I'm not aware of this.
Yeah, I mean it's dead now, but we actually
it got some data.
Yeah,
it sent something out before if it got.
yeah. But yeah, we got data on the corona. We got data on, and you can go on NASA, and they can based on because we have AI and we have some understanding of fluid dynamics. When two really hot pools of light, because you know the surface of the sun, it's volatile. It's not a flat surface the way there's volcanoes.
So there's eruptions
it's exactly
happening.
Right. So here's the thing: when really, really big eruptions smash into each other, they make what's called a solar flare. Yeah. And that amount of energy shoots out and will disrupt cell phones.
That's what they use in the movie, the Fantastic Four,
exactly.
to give them
the
powers.
You're right. Exactly.
It was a gamma
radiation. Right. Yeah. So solar flares exist, and the reason.
By the way, for anybody that, just to clarify, right quick, gamma radiation is just a fancy way of saying light. When you get hit by light, it's gamma is light.
Basically. Well, yes and no. So light is heat. Mm-hmm. That's all it is. Light is the light and energy is the same as saying how fast. So you have an electron, right? You have this thing.
Correct.
This thing is constantly moving, right? The electron around it is constantly moving, and then the whole thing itself is also constantly moving based on. Actually, he'll show you again.
So majestic.
So
There's so much
go back 1
structure and
second.
detail and so cute. And are
So
the excited states
literally right before the
beautiful? And isn't the ground state?
So that's ground state. Ground state means that is if you put it down to 0 Kelvin. 0 Kelvin is there's zero heat. There's no such thing as cold, by the way. It's just
the absence of heat.
Right. Yeah. So heat, absolute zero, is when you can freeze a molecule with no energy, and therefore it stands completely still. That's the resting state, and it's completely artificial. The way we do it is we have these really, really big magnets, and we pump so much nitrogen into these magnets, and these magnets isolate this one atom. It takes megawatts of energy. Like one power station, I think the one next to Roosevelt Island, I think it produces 3.5 megawatts a day. I mean, you're spending 3.5 megawatts for a minute. A
megawatt would power, just for anybody to understand.
Just imagine.
How many homes would power a megawatt?
No. So ohms is the resistance of electricity. So you have ohms, you have current, and you have voltage. Mm-hmm. And those are the three. So ohms is actually how much resistance. There's a really good overlay. It's just easier for me to show you. But those are the three. Those are the three things of electricity. So light is just heat.
By overlay, do you mean a picture?
What? Yeah. There's you can see ohms diagram. Ohms versus voltage versus whatever.
Graph.
Yeah, graph. Or diagram. Just say diagram. Yeah.
Any of
No,
these?
there's a really good diagram. No, it's put funny diagram. Ohms. OHOS. Yeah, put funny diagram. There. That's exactly how I would describe electricity. I saw this and I was like, that's. Yep. So ohms is how much resistance is pushing against electricity. Voltage is that power, the raw power, and the resistance versus the voltage is the equation of that is how much energy is going through, and that's what we call current.
Correct.
So that is what electricity is.
Okay.
In all three of its forms. And this is really important.
So in this particular example,
Yeah.
is
So this is-
resistance is trying to
so-
get the current
so-
out of its curse, or is it stopping it?
No. So think of this as a copper wire. Think of this as a copper wire. And just like audio engineering or computer engineering or even your CPU, which has wattage.
Anything moving.
Anything powered. Anything electrically powered. Yeah. So that's what's real. So you have the resistance of whatever that material is. Because even you can't have something that's 100% conductive. If I have a meter of, so the two most conductive materials, the reason they're conductive is because they're missing one electron, and we call these valence electrons when you have two coppers, they're both missing one electron to have a full ring. So when two copper atoms come together, they actually share their last electron.
Oh.
And that's what makes them conductive. And rubber doesn't have that at all.
Yeah, because electricity just fills in.
Rubber and lead are one of the two most stable things on the planet, because uranium, remember I told you about that half-life?
Yeah.
When uranium's half-life is reached, it decomposes, just like a body does.
Yeah.
Decomposes and decomposes and decomposes. Guess what uranium and plutonium decomposes into?
I have no idea.
Lead.
Oh.
And that's why when you get x-rays done, and that's why when we have astronauts and we try and protect things, we use lead, because lead is literally uranium's grandpa. And that's why it can deflect radiation, a lot of radiation.
So they use the lead as shield.
And that's what we call lead shielding, yes.
Yeah.
So lead is the number one thing, unfortunately, Marie Curie found out the hard way. Mm-hmm. But yeah, that's why lead is so protective against a lot of radiation. Conductivity is the opposite of resistance. Conductivity means that you are provoking that energy to go through. What's really conductive? Salt and water. You put a toaster in a bathtub while it's plugged in, your body is experiencing the full voltage of what's going through that power line, right? That's conductive. Copper wiring. If I'm holding copper wire and you take a really high power, if you ever worked on a car, anybody who knows a high DC voltage won't kill you, but you stick your hand in a battery by accident.
It's not going to be fun.
It's not going to be fun. You're going to go, and we have what's called dermal conductivity. Our skin is made up of a lot of water and whatnot that makes us very, very conducive to electricity. Yeah. So copper is the cheapest one because there's a covalence bond between two copper atoms. You'll almost never see one copper alone because it needs that second copper. It's the same thing with oxygen. Oxygen has a covalent bond because on its electron ring, it's missing one, which is why we don't call it O1 when you're breathing. We call it O2 because in nature, oxygen atoms are never alone. They're always in pairs. And that's why when you call it an O2 mask, we call it an O2 mask because the oxygen pairs up because they have a covalent thing. So the way oxygen pairs up naturally, copper does the same thing, and that's why we use it for speakers. That's why we use it for batteries, engines. Anything that you have to run electricity through is made of copper. Now, if you look at the periodic table, the one just under that with the same covalent bond is...
Gold?
Gold.
Thank you.
More expensive. It's a rare metal. And ironically, little history lesson, gold is the first metal used by humans. It's not copper or metal.
Wow.
Yeah.
So
really
swords
soft.
Were made out of gold?
No. It was too soft. The first metal was used to like adorn things.
Yeah.
But everyone thinks because sword in like the Bronze Age, everyone thinks, oh, copper for fighting. The first metal was actually used to be cute. not to kill shit with. Yeah.
So before, what you tell me is before fighting, before shielding and
before
armor
the
plates.
first person who
we
saw,
had jewelry.
Yeah, so the first person that looked at a rock and went, "Huh, that's shiny," and
Yeah,
took it out and
it looks
shaped
nice.
it. Yeah, he heated it up a little bit, and you can bend gold with your hands.
Yeah, it's very soft.
Yeah,
It's very soft.
Whereas so the Neolithic era is when we started domestication. Is when we stopped being hunter-gatherers. Actually, the Neanderthals were still alive at the time, and so we fucking killed them. And then it happened in the Eurasian area. So like Turkey, Mesopotamia, where Iraq is right now, the Tigris and Euphrates. This center thing is the Neolithic revolution, or we were taught in the 90s it's the Neolithic revolution. In reality, it's the Neolithic package because it has to do with domesticating animals and plants at the same time. It happened at the same time, and that's when intelligence overtook nature. That is the moment in time where humans were no longer part of the environment. We became above the environment, and we started terraforming the planet, changing the DNA of sheep and grapes and whatever.
Cloning them.
Yeah, and that's actually the one reason why modern vegans today are terrible, because they always say, oh, like antibiotics and like sheep and whatever. They don't realize, do you think an apple was that big when an apple first came? Do you think a strawberry is this fucking big? Those strawberries are as genetically modified as those cows and those dogs.
Or
and those
if
sheep.
not modified, at least they've been what's the name of that process when you just breed something into its better?
That's
better?
yeah. So domestication.
Yeah,
That's domestication.
Yeah.
Grapes
They
are
were
domesticated.
domesticated,
Yeah. We domesticated animals because we domesticated plants. We started planting first before some idiot saw a wolf and went, I could touch that.
Yeah.
Can you imagine how many?
I could probably pet it.
Yeah.
It's cute.
Can you imagine how many times it took guys to put a hand on a wolf's head before the wolf eventually was like, all right, I'll let this happen.
Yeah.
Bro, I gotta tell you, every time I look at my dog.
By the way, for anybody that doesn't get that reference, we're talking about dogs.
Yeah.
Okay? All dogs, even Shih Tzus and fucking Yorkies. It's just
Chihuahuas.
wolves.
Can you imagine a Chihuahua the size of a dire wolf and realize that thing came from? And that's how you know dogs came from wolves, because I don't look at an Alaskan Husky. I don't look at a Great Dane and think, no, that thing was a wolf. I look at Chihuahua and I think that thing was a fucking animal.
Yeah.
That thing was a beast. Can you
Yeah.
imagine that in nature?
Yeah.
300 pounds. Can you imagine a 300-pound Chihuahua
They're
running after
assholes,
you?
by the way. Chihuahuas are assholes,
Oh my
bro.
God, bro.
Oh my goodness.
So I'm part of, I have got a pit bull, so I'm kind of a vegan dog owner. I'm always the guy that's like, oh, it's not the breed of the animal, it's the person.
Yeah,
Everyone's
it's the
like,
owner.
Oh my, yeah. So I am also a pretty radical leftist, don't worry.
Yeah.
Before we go on a hate rant. But there's this common joke, it's like the top 10 most aggressive dog breeds, and 10 is like, there are no, so 10 there, 9, there are no aggressive dog breeds, just owners, number 1 Chihuahua.
Except the Chihuahua.
No, it's just Chihuahua, that's the list. Yeah, there are no aggressive dogs, Chihuahua. It was number 1.
Bro. And people have them. Do you think it's because of Paris Hilton?
So the University of Chicago came out with a study in the 80s or the 90s, and they proved that the reason smaller dogs have more violent incidents or recorded or unrecorded violence than humans is because it's purely behavioral. When small dogs bite you, you don't care as much. You don't have the need to punish it as hard.
Yeah, so you don't retaliate.
Exactly, as if a German Shepherd or a Husky bites you and you live in a city.
You put them down.
You don't put them down. You hit them. You put them in a cage. You take.
Yeah, but I mean, when they not
one-up
bite you, but
Yeah.
when they attack someone.
Yes, exactly. When they're aggressive.
Yeah, they usually put them
You
down.
have a natural instinct because that animal can actually hurt you to do that. When little dogs do it, your sympathetic system. So you have 2 nervous systems in your body. You have the parasympathetic system and the sympathetic system. One is commonly known as the fight or flight.
Mm-hmm.
The other one is called the rest and digest. So these 2 systems are controlled by 2 things: your brain and your neurological system, and your endocrinological system. Endocrinology is the glands that make up what's adrenaline? What are these things called?
Are you talking about protein?
Not protein. Adrenaline. They make up glucose. They make up. Oh my god! When you have glucose and you have diabetes, you can't make insulin.
Insulin.
They make insulin, adrenaline. All these things have a name. I forgot. But all these things have a name because they're made up by specific glands in your body.
Yeah.
So those glands set either, hey, that big dog's attacking me. You get pumped with adrenaline. Your heart starts faster. You think slower, but you think dumber, but you think faster.
Yeah.
That's why everything when you're falling, you fall in slow motion because you're like, what the fuck?
Yeah.
If you can't do math in that moment. If someone takes a gun out on your face, you can't.
There's
do math,
no time
but
for
you can run
problem
faster
solving.
than you could ever run before.
And lift heavy objects.
The
mom and the kid.
Exactly, right. The other one is rest and digest. And that's what happens when you get sleepy after eating. Mm-hmm. You eat a lot, you get a lot of glucose, and then your body, seeing that there's a lot of sugar in your blood, your pancreas shoots out insulin, which traps the glucose, and that's when your blood sugar drops. And that's why every single time you eat a large meal, you're like, gotta like.
Yeah,
that's called rest and digest.
You want to sleep.
Your blood pressure literally goes down. Like your heart pumps less, and it's similar to the diver's reflex. If your ears and your eyes are submerged under a liquid, this is not a conscious process. Your heart rate slows down because your body knows it's submerged and it needs to stop using oxygen because you can't breathe. And that's why swimmers out of all athletes have the lowest heart rate of any athlete.
Oh yeah.
Olympic swimmers will have. I know there's an Olympic swimmer that has like a 28.
Yeah, because the faster your heart pumps, the more
harder,
oxygen.
The harder.
Well, yeah, the harder your heart pumps,
efficient.
The most oxygen you need.
Yeah.
So your body knows that you need to keep all your oxygen now, so your
you
heart
don't drown. Yeah, exactly.
Yeah.
So the more efficient your heart pumps, the less times it has to pump. Very unhealthy people, the heart can't pump a lot, so it has to pump fast. Healthy people, every pump is a lot more blood, so it's less pumps. And that's why a slower resting heart rate is better.
That's another thing that I realized when I was a kid. The whole heart rate and just general muscle movement related to the amount of oxygen that I needed before I have to go up is because when I was... I've always been very competitive. This is a problem, by the way.
We both have this.
In a way, it's
the
good.
It's the gamer.
Yeah, in a way, it's good, but in another way, it's been a problem. Like there's been situations in my life where how competitive I am has actually been like shooting myself in the foot.
It degrades you because it puts you assign your value to a fake list, and people get depressed because of that. People get violent because of that. People play football. People kill their wives.
Yeah, exactly.
You know what I mean? Like,
it depends on how you canalize that energy, what you're gonna do.
Yeah.
And just to finish that story, I used to compete with. So the first school that I went to at the time, my family. It's not that we were wealthy. We were never really fucking wealthy, but. At the beginning of the 2000s, I got poor. Eventually, I was.
The family or you?
The family.
Okay.
But at the beginning, early 2000s, and I would even gonna say late 2000s. Anything before 2010s, we were fine economically speaking. Yeah. So the school that I used to go was this high school where they had a pool, and every once or twice a month they would take every classroom for a pool day. Why? I have no fucking idea. It was a very focused school. They were it was fun. They had like a zoo. Like they didn't have elephants or giraffes, but they had like
rare birds or some shit.
Exactly. Like they have like ostriches. They had.
I said rare bird immediately.
They had monkeys. They had.
Oh shit! Okay.
Bro, I'm telling you, these people had a lot of fucking animals. And they will use that to teach, but that's another topic. Anyways. So on pool days, my favorite thing, I never learned how to swim. Okay. I'm good at staying at the top.
Yeah.
But if
You
I
don't-
try to like actually go places swimming, I get tired very quickly because I'm inefficient.
Yeah.
Because I never took classes. This is something that I will do before I die. I will learn how to swim, and I will learn how to dance salsa and bachata.
You know what's
I have
funny?
these three things together.
Swimming is the easiest way to get in shape for anything else because it's the only
It's
sport.
complete as fuck.
It's the only sport that you're fighting for. Well, one, you're fighting for survival, literally, and two, it's the only time where you're submerged and you literally have to use every muscle, including the pinky.
Well, that and MMA.
Yeah.
You fight for survival in MMA too. There's somebody trying to kill you in front of you.
Well, yeah, but there's a difference between that. One is social and one is biological.
Correct.
You know that in a fight, there's rules for you to stop. So you technically it's not survival. You know the water will never forgive you if you chug enough of it. The water doesn't give a fuck.
Yeah,
So
you're dead.
There's a difference between social survival and real survival. So not even then.
Yeah.
Not even then.
So what I will do is,
The water's not going to tap out on you.
no matter how much you try.
Yeah.
Yeah. Actually, I'm gonna tell you a story in a bit. But at the time, I used to challenge kids. I'll be like, let's see who holds their breath the longest, right?
Yeah.
And I was very young
racing.
when I realized, that was another one. I like, but every time I race someone, and this is funny, since I'm so good at holding my breath underwater, I can. My record is over 2 minutes, by the way. I'm good at that shit. What I will do is, I noticed that when people were competing on how to who hold their breath the most, people will try to like go to the bottom. Right? And that takes energy. And I will do the same. But eventually I realized that if I literally just get on my bed, on my belly, and just
Slump.
literally stop moving any muscle on my body.
And even thinking burns oxygen.
Everything, bro.
Yeah.
If you want to hold your breath for a long time, you basically have to pretend you're like on a sensory depraving fucking tank.
Do you know what's funny?
You need to meditate.
Do you know what's funny?
Yeah.
You invented meditation.
Exactly.
You literally
exactly.
invented meditation. You and Buddha, when you were kids, both of you learned the same lesson, well, one was under a peach tree or pear tree. And
I was just trying to be kids for no reason.
You were in a school pool, but yeah.
Yeah. I learned that if I could stop every single movement, and I wouldn't call it thoughts, I would call them worries. I'll be like, don't worry. Don't try not to have any worries.
Don't work.
Don't do anything that spends energy because oxygen is the fuel, and if the more energy you spend, the more oxygen you need.
Exactly. Yeah.
So I when I was a kid, I learned that, and as of right now, every time I race somebody on water, I always add the caveat, and I'm an asshole for doing this, but fuck, like if it's a competition, you gotta put the odds on your favor. I will tell them we need to go there and back
on a breath.
Underwater.
Oh, okay.
If you come out, you lose.
Right.
And I've been beating people for years, bro. Like sometimes I get surprised.
So stealth swimming. You're you're splinter celling.
Yes, exactly. You're underwater. And
So it's not a race, more of a concealment thing.
It's more of I am
Navy SEAL.
tricking you into believing that you have a chance.
You turn water racing into a Navy SEAL competition.
Exactly. But yeah.
So small fact. You know what mitochondria is, right?
Yeah.
What is it? There's a joke on the internet.
Are you gonna do this again?
There's a joke on the internet. No, what's the common saying on the internet? What's the only thing you remember from biology?
I have no idea.
So in
mitochondria is a cell, right?
No. So in middle school and in high school, the first thing you learn biology is the parts of an animal cell, the nucleus, the mitochondria.
Come on. By the way, this is not gonna be the only time Stefan joins me on this podcast, and at this point, I've learned my lesson. I will never say yes ever again. Every time he asks me, I know what something is, I'll be like, no, what is it?
No, what is it?
You can literally ask me, what is Coke? And I'll be like, I have no fucking idea. What is it?
The difference between Coke and Pepsi, it's the same thing. One has caramel, which is Coke, and Pepsi has citric acid.
I'm also going to add something to that. on top of that, Coke is the only company in the United States that has ever been legally allowed to import cocaine for one of its ingredients. And when they decided to exchange it for legal reasons, what they did is that they use a byproduct of cocaine as a substitute. But they are the only company, I don't know if you're aware of this, but they're the only company in the United States that is legally allowed to import that product.
Non-medical company.
Well, yeah.
Yeah, I was gonna say,
the only consumer product.
Yeah. I was gonna say, because we
over the counter.
You know, we use cocaine every day for like anesthesia.
For a bunch of shit. But I mean, like the
consumer grade.
The only product that is consumer grade that is legally allowed to import either cocaine or a byproduct of cocaine. It's Coca-Cola.
Sure. Okay.
I had no idea why. Nobody knows why. They must have some really good fucking lobbies.
Well, it's also, I was going to say, it's like a 200-year-old company. Like,
fuck.
That's old, man.
Yeah, but they're not the oldest. Dr. Pepper existed before Coke. And they didn't get
Pepsi existed before all of them, right? Pepsi was sold as like a... Pepsi had codeine in it. Yeah. Pepsi had codeine in it. And it was sold to kids as a cough suppressant.
Yeah. They were sold as a medicine at the beginning.
Yeah. They're snake oil salesmen. Yeah. That's literally all drinks. Their grandparents were like, "Oh, you have necrosis? Try this. like your tummy, your vom, diarrhea. Try this."
Now that you mentioned that, did you know that at some point in human history, doctors were prescribing cigarettes to people?
Most of cigarettes' existence, we still haven't reached the age where it's not.
Well, yeah, but now they're like, oh, it's not good for you. Don't do it. In some countries, legally,
we've been making tobacco, I think, for like 200-300 years, right? It's only been bad for 40.
Yeah,
so 90% of tobacco's history has been endorsed by the medical society.
I mean, yes, but at the same time, it's not the same as me not telling you that this is bad, as me telling you. Drink this. No, you need this.
I'm saying for 200 years they've been endorsing it.
Bro, it's ridiculous.
Native Americans, when we got here, they were like, "This is awesome. You should try some. Like, it's good for you." And then white people, and then Spaniards were like, "He's right. Let's kill him and take all of it." Like, that's literally what happened.
Build a fence around them now.
There's two things that didn't happen before the New World, and people don't realize, is chocolate, cacao, is not native to anywhere other than the Americas. Yeah. And tobacco is not native to anywhere other than the Americas. We did not have cigarettes or chocolate anything, chocolate powder, chocolate coat, whatever, until Eric the Red and Columbus and what's his name, the guy who took down Tenochtitlan,
Hernan
Cortez.
Cortez.
Yeah. And Cortez came here, and we're like, because we knew gold was whatever, but they saw tobacco and chocolate. We're like, we're killing all of you guys for this. This is how good this is. And then,
by the way, now that you mentioned Cortez, and this is very quick, we're gonna go back. It's a quick segue. I was in Mexico not too long ago.
Oh shit!
Yeah.
Oh, you told me this. You told me in Mexico City,
bro. We need to talk about this, bro.
Yeah.
But I went over there, and one of the locals over there, he told me, I always knew Hernan Cortez was an asshole. I always knew it.
Yeah.
But he told me, I was actually impressed by how much of an asshole he was. Yeah. This guy went over there, noticed that he had a fight to have, and he enticed one of the local. It was a female native from Mexico, and he noticed that she was particularly good with languages, and he fucking enticed her into joining him, and then he used her to fucking fight around Mexico, to talk to people, to communicate. Like any war prisoners that he will get, he will use her to interrogate them and find out shit. And
so the Spanish Inquisition,
bro, that is ridiculous.
The most fucked up thing
that didn't happen in DR, by the way.
The only thing that was funny because Christopher Columbus landed in DR. No one knows that.
No one knows that.
Nobody, bro. When people think that in the U.S. it was because it was Italian Americans after the 40s.
He was never here. He never stepped foot on the
Bro,
U.S.
everyone thinks that he like landed in Massachusetts, like the Pilgrims, or like, bro, he never even stepped foot. And you know what's funny? Everyone's like the first castle. No, the first castle in North America is in the Dominican Republic. The first fort ever built was in the Dominican Republic.
The first college, the first church, the first anything.
Yeah, like anything other than the first landing, which was Eric the Red, and he landed in Canada. But they were smart, and they killed him immediately, or tried to kill him immediately. Yeah. But yeah, everyone thinks that, like, because Christopher Columbus, who wasn't even the first white person in this continent. Yep. Yeah.
That's incredible.
The most fucked up thing I ever heard Cortez do was he kidnapped the king of Tenochtitlan.
Yeah.
And then he was like, I'll give him back to you if you fill up this room with gold. And at the time in Tenochtitlan, there was two things that they made jewelry out of: feathers of their sacred bird and the gold. Guess what was harder to get? The feathers. Yeah, the feathers. They were like, we'll give him all the feathers. And Cortez literally took all these sacred, like, it's like I gave you my mother's gold ring, and you were like, fuck it, let's burn it all. Like, who cares about this fuck? Because he just wanted the gold, and they didn't understand that. Like, because he didn't want to tell them, bro.
Because for them, the feathers were
useless. It's from a
valuable.
bird. They didn't give a fuck. You can't sell feathers back in Europe. Like, they didn't give a fuck. But they cared about feathers. So hold on a second. So he destroyed the feathers. He destroyed the feathers. They listened to him. They filled up the room with gold, and he still killed the dude. Didn't even keep his promise.
He was
a
an
piece
asshole.
of shit.
He was an
Yeah.
asshole.
The fact that he survived any of the ordeals.
I'm actually pissed at that. Do you know the whole weeping story?
Yeah,
about
of
him?
course. Yeah. The weeping son.
Why they didn't fucking kill him then?
Because they
Like
thought
he already defeated.
lot
They
of
already
the
defeated
priests-
his
A lot
army.
of the priests were all like, "Listen, he predicted the lunar eclipse, and at the time they
Yeah,
blood
this is another
were-
thing. People
Yeah.
tend to think that Spaniards, or well, let's not just say Spaniards, because that would be a little
the
bit
Portuguese
racist.
were pieces of
Let's
shit.
say conquistadors.
The
People
Dutch.
tend to think conquistadors trick the natives with tools and shit. No, they trick them by using their knowledge
Yeah.
of astronomy and their knowledge of climate to predict and magically predict shit.
Yeah,
And they'll
like
be
a
like,
full moon.
fuck.
No, but to be fair, the other thing that really empowered them were horses. Natives had never seen a horse before, and to ride a horse. So the main reason Eurasians conquered the planet before
Horses.
any other was domestication.
Yes,
And-
they had horses to domesticate.
Yeah. So before the 17th century, guess how many animals were domesticated before the 1700s?
I don't know.
Guess out of all the animals we've domesticated right now,
6? I would say
13.
cows, pig.
And 2 of them is the silkworm and the honeybee.
Yeah, the closest thing we had to that in the Americas was llamas. And
Yes,
fucking
and those are
Peru.
camelids,
Yeah.
right? It was the only domesticatable animal in the Americas was the llama.
I was actually explaining racism to somebody not too long ago, and I told them about this, and they were like, "Fuck!" Like the only reason why Europe went as far as they got before the Americas is because they had the animals that could do shit for them.
And llamas are the worst camelids because camels have less attitudes, and alpacas have also less attitudes, and they're kind of bigger than llamas. And that's why in Peru they have the longest and oldest and biggest temples because
they have something. They have something
they had llamas to be able to move shit. Yeah, of course. Yeah, and
we have none. We have
and
neither llamas or
Africans-
horses.
In Africa, they had zebras. Bro, zebras don't give a shit about their family. If you kill a zebra's mom or dad, that zebra doesn't give a fuck. And I didn't know this. Zebras duck. They duck naturally. If you shoot near a zebra will duck. Horses don't do that. Yeah. So,
and the Native Americans here, they have buffaloes, which are assholes.
Bro, nothing in this continent, moose, are not even social. They're not social among each other. A moose is a deer with armor. Like, they will kill you. Buffalo are herbivores. They won't kill you for food. They will kill you for fun.
Yeah.
Egyptians, ancient Egypt, the first people to store grain for a long time, the hippos, do you know, hippopotamuses are so dangerous that when they built the Great Pyramids, they believed in the afterlife. They're one of the first civilizations that believed in the afterlife. What they would do is the hippopotamuses were so dangerous that they would have a statue of a guardian hippo in front of the temple of their kings to protect it. But they were so scared of the hippos, they would then break the statue's legs so that the hippo couldn't move. That's how scared of hippopotamuses. Hippopotamuses? Whatever.
I have no idea.
They were, yeah. So every pyramid has a hippo guardian statue, and they smashed their legs. That's how scared they were. They made a fake figure and then destroyed the figure just in case.
They're assassins. And now that you mentioned that, just as a funny note, they're having a hippopotamus problem in Colombia. Are you aware of this? Because of Escobar.
They're invasive.
So
and they're
Escobar brought this whole
12.
African zoo to Colombia.
I think there's 12 hippos, 12 or 13 hippos.
Yeah, they were his pets basically.
Yeah.
And when they were done with him, these assholes didn't fucking get the animals out, and now they have reproduced to the point where
400 in one town.
Yes,
400 hippopotamus.
Now they have a hippopotamus problem in Colombia.
And hippos' shells, they're not like rhinoceroses. They're not that armored. But a 9mm will not pierce a hippopotamus. Like a 45 will not pierce. Like you need a high power rifle, and you need to kill it before it kills you. And they swim.
And they're so aggressive. They're fast swimming.
They run. They swim. They run, and they can climb to a certain point.
Yeah.
So you're not getting anywhere.
It's a crocodile mixed with a cow, mixed with a
it's a cow
rhino.
Crocodile. It's literally cow crocodile.
Yeah. They will get on water and they will swim fastest than.
And you wouldn't think so. You'd be like, it looks like a water bear to me.
And they're
like
heavy.
Yeah.
They're heavy too, so they can ram you.
Blubber.
And fucking turn your
armor.
cars.
They have armor. Yeah, you can shoot it. And there's so many hippos that have been captured, and you'll have like 8-9 bullets in them, and they'll just like, oh yeah, he must have been shot 8 years ago. What? 8 years ago? What? I've seen videos of like, because African hunting, safari hunting is a thing, and so they'll have guides from Africa, and you'll have rhinoceroses, you'll have like whatever, and they'll have like solid ball tungsten like shotgun shells in their back, in their ass, where they're the strongest, and like whatever, and they're like, oh yeah, you see that? You see how it's healed over? Yeah, this must have happened when he was a teenager or something. You're like, what? This thing was shot with a shotgun a bunch of times and lived a full life and had kids and whatever and didn't see a doctor once?
Like getting rid of hippos is a problem.
Yeah.
Is a problem.
But yeah, so that's why when he came in with horses, they thought this guy could tame a buffalo or a horse. They've never seen horses before, so they're like, this is a god. Like this is So it wasn't so much as like they couldn't, as opposed to they're very religious, and there's when religion comes into play in a society.
I gotta take a pee break.
When religion comes into society, it really is like a give and a take.
So wait, before I get away, you were telling me before this.
Oh yeah. So an electron. So you want to talk off here?
No. You can say it.
Okay.
So an electron is. I'm listening to you.
Okay, yeah. So the reason we use conductive materials is because it degrades. Like, let's say you have a foot long of copper wire, gold wire, and like lead wire. If you put a battery on one side and then you have a tester on another, the gold and the copper will have 99% of the energy, because 100% of the energy never passes. There's always some degradation. Same thing for fiber optics. Like our internet, if you shoot a fiber optic, is literally just a laser going down a Kevlar vest jacketed pipe. It's called attenuation. At a certain point, and we're not talking about distances of a mile, 10 miles. We're talking about distances of 100 miles. They're called submarine cables. The submarine cables that are the internet between Europe and the U.S. Those are cables. Those are fiber optic cables. Those are not like. That's not internet.
It's not copper.
It's not copper. It's glass. It's glass and Kevlar.
I actually learned this not too long ago, by the way. I think it was like a year and a half ago when I realized That because before that I thought we had internet because of satellites and shit, but it turns out
No.
there are cables
90%.
underwater that go from the U.S. to the Caribbean and to Europe. And so
No,
on.
so when people think about like water infrastructure, so when we're talking about infrastructure, we're talking about gas, power, which is electricity 90% of the time, gas, power, water, and now telephony, which is either RJ45 or RJ11, which are those phone clips that you see, that jack with the little clip on it, right? Everyone always asks me as a computer engineer, like, what's the internet? Like, where is it? Like, where is this website located? And forget about what DNSs are and what web hosting is and whatever. You have to realize the reason that you can send an email to somebody else is that you are literally, when you plug into that Ethernet cable, are physically connected to every computer on this planet. Every computer on this planet. And it's the same way water is.
In a way or another.
Literally. If I had an infinite amount of energy and I wanted to send a source and I plugged it into that cord leads to, if I follow it through every single medium,
everywhere to the world,
goes to that Indian guy who makes the YouTube videos about math, or the Chinese guy who's hacking credit cards, or the crazy Putin's
Russian
office,
hacker. Yeah.
Putin's office, Obama. You are literally connected, and that's why it's so hard. The internet isn't hard because it's like super mathematical and yes, more advanced.
It's
obviously.
physically connected.
It's because you have to have a guy dig a hole in the ground and lay a pipe, and that pipe has to be corrosive resistant for water, gas resistant for
air pockets.
For air, exactly, for not ethanol, not kerosene. Whatever the gas powers the
methanol.
No, it's not methanol. It's you're thinking methane.
Methane.
No, it's not methane. Whatever that fuel is to the oven, is you are literally connected to a power plant. You are literally connected to a whatever. Now, how many connections between here and there is hundreds and hundreds and hundreds. We call them nodes. There's hundreds of nodes. There's hundreds of splits, and that's why we have a transformer. A transformer is that cylindrical metal thing that's attached to the metal
it's like
poles.
a repeater, but for electricity.
Exactly, right.
Every time
it changes
electricity
one charge
is
into
getting
another. Right, exactly, yeah. So that's what a transformer is. At a certain point, but if you were to become Ant-Man and travel through it, you could literally go anywhere. And that's why it's hard for internet. That's why it's hard for gas. That's why it's hard. It's because physically there's guys mining rocks. There's guys smelting it. Then there's industrialists who make it into a shape. Then there's contractors who buy that, make it into pipes. Then there's construction guys who dig where the pipe has to go. You put the pipe in, you put the lines in through the pipe, you build a building, you put the building around it, the building has building codes, you have a house, you have electricity, gas, water, internet. And it has to be done for every of the 7 billion people, humans, and that's why global warming is a problem.
In a perfect world, because we both
obviously,
know
there's people who don't have
most
that.
people don't have any of that shit.
Yeah. But that's what happens. That's why it's complicated. But back to this point, covalent bonds. So copper and gold are the most, and there's more expensive ones, but to mass produce anything more expensive than gold is insane. Actually, mass producing gold is pretty expensive anyway. You lose energy. So same with the fiber optic. At 100 miles, if you put a straight laser through a straight pipe, it's never straight, based on pressures, atmospheric settings, whatever. It's always so it'll bounce. It's a type of attenuation. So then you have to reconnect that laser, and then reconnect it again, and then readjust, and then readjust, and readjust, and readjust. And then we've gone so many tangents, I forgot where I was going with, because we were talking about the Big Bang. But that's a good. So ohms is how we rate the resistance. Wattage is how we rate currents, and voltage is
Yeah.
voltage.
So just to keep you back on track,
Yeah.
the reason we're talking about this
Yeah.
is because we were talking about realities and the fact that these new technologies are going to shape the way we see everything.
No, but we was past before that because
We're talking about dimensions.
uranium.
Before this, we were talking about
Yeah,
dimensions.
but we were talking about uranium and I forgot why. So lead, black holes.
Yes.
Yeah. So he theorized black holes where gravity overpowers so much energy that there was no space. And then Stephen Hawking thought, well, that's impossible. You can't have no space in a place where space is.
Yeah.
So he realized that under a certain lens, light. That's what we're talking about. What is light? So light is heat. And then when you have no energy, you have no heat. So when you're at 0 Kelvin, you're not giving off what's called radiation. And that radiation is in the form of light. And we have what's called a light spectrum. And we have
It just sounds so good. Yeah.
So we have the visible light spectrum, and then on both ends we have non-visible light spectrum. So actually you can pull that up too if you want. But this is all radiation.
Non-visible light spectrums?
No, just put in light spectrum.
All right.
Wikipedia light spectrum.
Which one?
You can go to electromagnetic spectrum. Yeah. Oh no, there's no labels on. Oh, actually, yeah, there are labels. Okay, yeah. So here we go. So it's not energy. It's not energy. It's the amount of heat that gives off the atom. So the amount of energy that atom has, based on the atom, it moves. So at 0 Kelvin, we can freeze atoms and have them almost motionless. And that's actually what they do at CERN, is when you shoot them together, what you do is you freeze them as cold as possible, and then you shoot them at each other. And then you shoot them at each other, and that provides the highest possibility of I forget what they call it. It's a trigger. It's a direct action. I forget what they call it. It's the word. There's a sciencey word for it. But when you don't freeze it and there's heat, the more energy that atom has, the more it moves, and it moves pretty sporadically. Actually, like this, kind of like how an electron. But the difference is an electron is in multiple places. An atom actually moves the way you and I move, like this. So a frequency or a wavelength is how many cycles per second it is. So we call that frequency. Not FPS. What's look up frequency per second. Literally like the one word I want to come up with. Hertz. We call it hertz. There we go. Yeah. So that's what a hertz is how many things it goes from one end to another in a second. So that's how you measure frame rates. That's how you measure audio rates, sampling sizes of audios. Yeah. When you see 550.
Processing units.
Anything. Hertz.
Sound.
Yeah, exactly. Right. So it's just one cycle per second.
Of light or energy?
Anything. If it happens in a cycle, if the thing goes from one state to another state and back and it's uniform, a hertz is not what that is. It's not the distance between stage 1 and stage 2. Hertz is a measurement of how many times it goes from stage 1 to stage 2 in a given amount of time. So if your monitor is not, let's say a monitor flickering is a lot. It's energy, it's light, it's whatever. But all those together is how many times that screen can change images a second. So we put that all together and we say, well, how many times per second is how many hertz? So 1 hertz is your screen resets once a second. 160 hertz, or 60 FPS, or 60 hertz is 60 times a second. 120, 120, 244, 480, things like that, okay? So when we have hertz and we apply it to the electromagnetic spectrum, or what heat or light or magnetism, which ironically is actually all the same thing. Magnetism and light is the same thing. Yeah. It's just measured different. It's just we tend to look at them different ways. But in terms of how many hertz, which is basically when it moves from point A to point B, how many times that happens, how many times frequently, we can actually see that. So the visible spectrum is right here. We can actually see between 10 to the 15th and 10 to the 16th. That's the visible spectrum. That's red, white, blue, violet, green. If you can see that color, it's in this section. That means that that atom is moving.
This is what our senses allow us to.
Well, technically, we sense all of it. Your brain just doesn't comprehend it with your eyeballs.
Sorry.
Yeah, so your eyeballs.
This is where our eyeballs have evolved to be able to feel and sense.
Yes.
Well, not feel, sense.
Yeah.
It's
well, no, it's not sense. It's your brain can interpret that information. Your brain can interpret that information in some way.
And just to put it on layman's term, if you had
basically you can see this.
Yeah. If you had but just in case, because the thing is, I'm not quite sure how good is the camera at catching whatever I put here.
Oh, I see.
And that's why I usually record the screen. But
you
today,
can post,
today, I can find this later. Yeah, but if you had, let's say, 30 centimeters ruler, and all of those 30 centimeters is what the light composes. Just half of one of those centimeters is what we actually get to see.
So
anything else is outside of that.
So this is a good example.
Yeah.
This can be your 1 foot ruler.
Correct.
Or 1 meter ruler, right?
Yeah.
This is from one. This is from 1 hertz a second. So this is from going A to B, and then this can go near infinity. I mean, this goes infinite. We just can't. There's some power sources that are insane, but 99% of all heat or energy, which is the same thing, or magnetism or electricity or light or heat, which is all the same thing, is on this scale. And basically it means that the atom is moving from point A to point B
in that amount of seconds.
That many times a second.
Oh, that many times a second.
A second, right. So this is all 1 second.
Yeah.
So the wavelength like this, we use, because we're humans, we use seconds.
And these are tenths, and then this is 3, to the first, to the second. Is that how you say it in English? To the second,
to the third power,
to the third,
yeah.
Right.
Okay, so the slower actually you can see this, you can hear this visibly in bass. Bass is really wide hertz, and it travels very, 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 very slow because it's very, very powerful. Whereas higher, the trebles and the hi-hats and whatnot, they don't travel. They travel much faster, but they have a much shorter range. You can hear a car's bass further away than you can hear the hi-hats in the song.
Yeah, absolutely.
Yeah, and that's because the frequency at which bass goes is much broader, and the treble and the hi-hat is much smaller.
Yeah.
So faster, longer.
Therefore, bass also creates more vibrations too.
That's
right?
literally what it is.
Yeah. Because
it's so powerful, and that's literally why when you see a speaker, that bass will move that cone. It's called a cone. That cone, you just don't see it because it's covered by the plastic. That cone much harder than a hi-hat will, that very hi-hat. So it's the same as how we see things. So what we see things is a very
small,
what all things.
This is what, like a 20th?
I don't know. I don't want to give it a percentage, but
it's like 5%, bro. Yeah,
20 is good. Yeah, because I was at 10, I guess. Yeah, 20, yeah. So anything less of that is very, very weak, and we call this benign. We call this benign energy. The reason we call this benign energy is because the energy that the light is emitting is so weak, the hertz is so small, is that it can go through our bodies and it would not cause any damage to your cells. Your cells can either repair faster than damage is being done, or two, it's spread out so much that it doesn't actually puncture any of the atoms in your body. So that's why we have AM and FM radio towers everywhere. Right now, we're getting bombarded with radio. We just don't have a radio to hear.
We can't feel it.
Yeah, you can't feel it.
Our senses won't allow.
Which is why we have the antennas, right? So your car radio is coming from radio towers, satellite towers everywhere. The energy is so weak that you can be constantly bombarded by it and you'll never get cancer from it. And that's what we call, on the weekend, we call them radio waves. Radio waves can be separated into frequencies. So AM and FM, AM means amplitude modulation, FM means frequency modulation. That's whatever.
I had no idea.
Yeah.
This is a new concept to me, that radio waves are actually light.
Yeah. Everything electric and anything that can transfer from one point to another without a medium, the medium being the air, is light.
And then
or electricity.
On the
or
other
magnets.
spectrum of this, how do you call this?
So here's the thing. So we call these benign lights. So basically, radio waves, microwaves to a certain point, and then infrared or infrared, depending on how you whatever. So this is when there's so little heat that we actually can have very, very weak scopes. I think the first infrared scope was made like in 1800 whatever. We can almost see it, and that's why
I'm gonna need you to give me like 5 seconds.
Yeah, for the bird.
I can hear you, so you can keep.
All right. So the infrared, because we don't see it when we see thermal imaging. It's just weird not talking while you're here.
Yeah.
So, infrared is the reason why all night vision goggles, we call them bicolor, and they're categorized generally 3 and 4. So we call them green on black, white on black, black on white, or black on green. Which means that if you ever played any video game, any military game, Call of Duty, whatever, and you put on thermal goggles, you'll see the heat sources is white, and then the background is green where it's cold.
Yeah.
Or the more modern ones and the more accurate ones it's black, and then the heat sources are white. That's because we can't see the infrared. The camera sees the infrared. So what we do is we transpose whatever this is into white, and then we chose whatever the thing is into green or black. So cameras, that's what we call FLIR. Like FLIR cameras are white on black cameras.
And this is actually a concept. I know I keep bringing stories of when I was a kid, but this is a concept I actually discovered when I was a little kid.
Yeah, trying to come up with new colors?
No, I have an uncle, very dear uncle to me. He's like a father figure, and he gave me a camera. But do you remember those cameras that you'll hit a button and they will open and there was a cassette on it? Yeah. That camera had night vision.
Oh shit!
Yes, you could toggle an option in it, and it will allow you to see shit in the dark. And it was the whole green thing, like
green.
Bro, I'm telling you, I was like probably 10 years old, 11 years old.
That's the coolest shit.
And I will grab my room, close the door, close all the windows, turn everything dark, and just use that. And at the time, I didn't have internet. This is a thing, by the way. I know in the U.S. you guys have been had like consumer internet for since what? Since before the 2000s, right?
Yeah. Like generally, cable started becoming popular in mid-90s.
Yeah, we had dial-up in 2004, 2005, and we had flash internet, which is the way the company used to call it. I don't know if they call it like that here, but we had flash internet like around 2007, 2008.
Okay. Right.
So
like a 5-year gap.
Yeah. So when you were downloading shit online or playing online games, we had no idea of any of that in my country, and the reason is this is a topic for another podcast when I speak about. When I talk about Dominican politics.
Oh, okay.
But the reason is because we had a president that, for some weird reason, and I say weird reason because this guy was a genius. He was a dictator, but he was a genius at the same time. At least politically speaking, he was against computers. Why? We have no idea. So he banned computers from my country. So until 1995.
So they're gonna do that often. It's called information control.
Yes.
Yeah. It's not a weird reason. Every dictator does that.
Yeah, but at the time, it's not like you could get. Well, I mean, computers have always been amazing tools, but at the time, it's not like anybody was gonna overthrow it because of them. You know what I mean? They were not at this point. There was no social media.
But we're not talking. But we're talking about, when you talk about a country, you're not talking about one, two. You're not talking about a movement. You just like Putin in China and North Korea. It's not about a specific person or a specific movement. It's when you talk about millions of people, even a 1% chance applied to millions of people, you're unnecessarily increasing the risk for little benefit. Because it's not like one president's going to be like, oh, I'll give you guys better internet, and then you'll vote for him for that. There's no reason to do it. That's why. And that's why a lot of poor Chinese farms don't have, they'll have every other utility except the internet. And they don't need it because you have books, you can live your whole life without the internet.
Come on, bro. Internet is a tiny thing compared to human existence.
Yeah, exactly. Yeah.
But
that's why it's not a weird thing. It's your and on top of that, the other big thing is he could have been the guy who would have been importing the copper cable and whatnot might have been his opponent or working for his opposition.
Maybe, absolutely.
Yeah.
Like the details, I don't really know.
Yeah.
I will, now that you mentioned that, I will definitely look into that.
Copper mines are a very, very huge political force that people are not aware of.
Yeah.
Copper mines, copper, gold, nickel, dictate the quality of life of people. And because it's a raw metal, everyone thinks like
but
mine cakes and coal and guys and hats and whatnot. But actually, to be able to repair streets and have gas and lighting and advanced internet is expensive. And the business guys that are importing it and the companies those are worth trillions of dollars of infrastructure money. You're not paying pennies. That's a large part of your budget.
Yeah. Whatever.
Biden's $3.5 trillion infrastructure plan is just that. Is literally resurfacing
more
roads, building more cables. And guess what all that is? Coal, copper, zinc, all these metals. And it's not in 10 pounds. It's not we're talking billions of tons produced.
So, because of this weird decision that he had, we didn't really have computers on a consumer basis until the late 90s.
Yeah.
So if you're just being introduced to computers, obviously internet is something that comes after.
Yeah, of course.
You first have to know what the fuck this is before
games.
Nobody was playing games in my country until mid 2000s.
Yeah.
Maybe early 2000s. Obviously, there's some adepts that probably did everything they could to get it.
Of course,
There was people traveling to the United States that were probably also getting familiar with it.
Yeah.
But the point is
the
because
population was talking
the layman population. They didn't get internet before the 2000s, and then we got it, and it was slow for years. So
can't call and go on the internet at the same time.
And that led to a bunch of things that we actually missed out, because you know how the internet works. Like if people,
fads. It goes away. Once it's away, it's away. It's done
exactly.
Forever.
If
I'm never gonna play Pokemon Red again.
Exactly. If we were living in a village now in India where there's no internet and we get it right now, we're going straight to TikTok.
Yeah, exactly.
We're not gonna go. You're not gonna play Neopets.
Yeah, exactly. Exactly.
You're going straight to TikTok.
The era is done.
Exactly.
Yeah.
So, because of that, there's a lot of stuff that we missed, and our internet was very slow at times. I mean, not at times, for a long period of time.
Yeah. That makes sense.
Yeah. And it's funny because now Dominican Republic is like up to date. Like if every time I'm comparing Dominican Republic to another country, I'm not comparing to the U.S. Obviously,
Yeah,
I
you're
compare
talking
it
about the world. The
to
rest of
Mexico.
Latin
I
America.
compare.
Yeah.
Exactly.
Yeah,
I compare it to Latin America.
Yeah.
So compared to
It's called geographic
relevance.
relevance.
Yeah. I every time I compare my country to another country, I'll compare it to a Latin American country. And when you do that nowadays, the Dominican Republic it's not up to date because they don't have 5G yet, but it's up to date compared to everybody else in Latin
you're like
America.
tier 2. Yeah.
Or one, bro. You know what I mean?
Exactly.
Like
You're
they're doing good.
You're
on
not
that.
you're not in the middle.
Yeah,
That's what I'm saying. Yeah, you're not in the middle.
Exactly.
Yeah.
There's Teslas in the R.
Exactly.
You know what I mean?
Exactly.
Yeah.
So visible light, which generally infrared and visible light, most of this is unharmful, right? Then when the more energy an atom has, that's when the frequency becomes way more like this. Now, the more compressed the frequency and the higher the frequency, the more energy it has, the more that molecule moves. The more that molecule moves, think of a bullet in a room. That will ricochet. That bullet, you shoot a bullet in a room and it will bounce off or whatever.
Until it stops.
That's exactly what happens at the cellular level. And the first dangerous one is actually very, very dangerous, and it's the very, very last 1% of the sun's rays that hits us.
Ultraviolet,
right. So, and then that's further divided into ultraviolet A, B, C, whatever. But for the purposes of science.
Before you keep going, if I buy a pair of glasses at a 7-Eleven that says that they are ultraviolet, like they're protecting you from ultraviolet, is it true, or am I?
I mean, yeah.
You think it's true?
I mean, UV lenses are cheap to produce.
Okay.
And
that was just a question that I have personally.
Let me answer your question scientifically, and then you can take from that what you want. Ultraviolet lenses are cheap to produce.
Okay.
Whether or not those glasses can protect you against ultraviolet, an easy way to do it is you can get a laser.
To find out, you mean?
Yeah, get on Amazon.
Yeah.
There's all types
I got a
lasers.
laser.
Yeah, get a UV laser, get a UV A, B, C laser, and then literally get a lens or a camera, and then just shoot it and see if it comes out the other side. That's the easiest way to test.
If it doesn't,
all scientists, if we don't have an answer, you put it in a room with 100 things of the same thing, and you just do it slightly different, 100 different ways, and see which one works. That's the basis of all. Everyone's like, scientists are so smart.
Trial and error.
We're not smart. You make a spreadsheet and you do something 10,000 times. And if 8,000 times one thing happens, that's probably what's happening. And then you write that down and then you move on. And everyone's just like, you have to be so smart to go to... No, you don't. You just have to be very tedious. And you have to be very, very meticulous.
Yeah, and try to think of as many possible different ways of doing this as you can.
Well, to be fair, you're not even... To get to that level, which is when you can change science. So when you can change science, you become what's called a doctor. A doctor of philosophy, is PhD. And we use the term philosophy in the original Greek meaning to learn, not why am I here. So that's what a doctorate is. A doctor... has produced a piece that has changed knowledge. Every single time you become a doctor in the United States, your thesis goes into the Library of Congress for eternity. You have changed, whether or not you've discovered something new or not, is irrelevant. If your thesis is peer-reviewed, which it is by your university panel, and it's agreed upon and your thesis is accepted, and you are granted the title of doctor, you can now legally change reality. You can say, this color causes cancer to people with certain genetics, and if you have a thesis that proves that, on Wikipedia you can write that down and it stays on Wikipedia. Yeah. That's a reference. You become the reference.
Yeah.
That's the difference.
It becomes common knowledge.
It becomes reality. Exactly, knowledge. Right. So that's the difference between a doctor and a non-doctor. Where people think doctors, they think medical doctors, so that M is. There's medical doctors not the same. And ironically, medical doctors, everyone talks shit about people who call themselves doctors. But in reality, medical doctors can't create new diseases. They can't research. Medical doctors go off of the teaching of PhDs. And it becomes when PhDs do something in theory, only after the theory is credible does the MD do it in practice. And most medical PhDs have MDs anyway.
Plus all the bureaucracy, the FDA, and then.
Well, that's what I'm saying. So in theory, that's what the bureaucracy is. Unfortunately, to get a PhD, you need a bachelor's and then a master's. That's the bureaucracy. Because I'm sure you have an idea that 100% will be true.
Yeah, but if you
can't go straight to changing up.
Yeah.
You have to go 4 years bachelor's.
And if you do, you're gonna be people are gonna you're gonna Photoshop a tinfoil hat on you, and that's it.
Even though you might be the bureaucracy is getting the degree. That's the bureaucracy. But once you have it, 99% of the bureaucracy goes away. The FDA doesn't care because you are a doctor in a relevant field. The only time that you would get in the way is if you're like a target, like if a former president of ours has favorites who played favorites a lot.
Yeah.
But to be fair, those are very rare cases, and wouldn't whatever.
Yeah.
So this is the very, very tail end, and it only becomes ultraviolet when it hits us because the sun, 193 million miles away, like electricity, energy depletes. So standing next to the sun, you're going to get way more radiation than standing on Earth, and you're going to get way less radiation if you're standing next to Uranus. But
just by standing, not even next to the sun, just by standing outside of our atmosphere.
Exactly right.
Yeah, no more shielding.
So the distance, it plays one part. The second part is what you just noticed, is the atmosphere, is the shielding. That's what makes Mars really complicated, because planets in our solar system anyway, in the Milky Way, specifically fall into two categories except Mars. It's either a gas giant, and it's very, very gaseous, and it's a horrific atmosphere, and you can see straight into it, and there's nothing solid, and you can whatever. Then there's rocky planets with no atmospheres. We're talking about Mercury. One side of Mercury is extremely hot, and the other side of Mercury is extremely cold, because one is facing the sun and one is facing away from the sun.
It goes to the extremes. Yeah. It's total or total.
And there's no clouds at all. There's nothing protecting that. It's literally a rock in a microwave, right? So it's easy to land rovers. It's easy to design rovers specifically for just things that are gassy or just things that are rocky. The problem with Mars is, and the reason why everyone thinks there's aliens there or it's our next habitable planet, is just like Earth, it's both. And that's why it's so difficult to land. Oh, the moon, another rocky, no atmosphere on the moon. It's just like Mercury. You could literally...
Yeah. If you jump too high, you're done.
Yeah, they literally landed a rover on a rock, and then he put his footprint on there, and that footprint is probably still there. Like, it has not moved. There's no...
No, not even probably. They say it. It's factual. It's still there.
Well, it's moving a little bit, so it's not, like I said, reality is not perfect, so...
Yeah,
specs do...
1,000 years from now is not going to be there.
Exactly right.
But right now it is.
Exactly. It's not like Earth. In Earth, if you put your foot on sand, 2 seconds...
2 weeks.
Exactly. Yeah, 2 seconds after the wind blows. Yeah. So the problem with Mars is it's that perfect combination of it has an atmosphere and it's rocky. So to be able to land on something... And that's why whenever you see NASA control rooms, when they land, they're like, ah!
Yeah.
It's because they're literally shooting a bullet while that bullet is traveling and that gun is traveling, and like I said, bro, 2 megabytes a second, and it takes anywhere between 30 minutes and 4 hours for one data packet.
Well, data packet.
A data packet, not even a fucking photo. So if you want an HD whatever, you gotta do that. Oh, so and there's one node between us and the satellite is fine, but between that satellite and Mars. That's where all the problems are and whatever.
Yeah.
So it gets, the sun's radiations gets really, really weak because one, of the distance, and two, we have an electromagnetic field around us, and that electromagnetic field, that's the difference between magnetic north and real north. If you ever see it, it looks like this. And polar north. And
it's going up,
exactly right.
out, and then in.
And sometimes it flips.
Yeah.
Sometimes it flips from north to south. Yeah. So that magnetic shield around us is protecting us from 99% of the shit. It's the only reason it's a hospitable life. 99% of all the bad shit gets filtered out from that shield. Cloud cover, which is vapor density, which is basically just forms of water, does it a little bit, but 99% of that is from the electromagnetic field. And so once it reaches through the clouds and the electromagnetic barrier, it hits you. It bounces off of a skyscraper, a mountain, whatever. And by the time it hits you on the ground and you're walking, it has become ultraviolet A, B, whatever. That is harmful enough to give you skin melanoma and cancer. Just that tail end. And the tail end is just the tail end.
Yeah.
So X-rays are 90% of X-ray machines.
On that note,
yeah.
Wear sunscreen, please, everybody. Nobody does it, but please, if you're going out, wear sunscreen. Yeah.
So X-rays, most X-ray machines that we have are from a thing not as powerful as uranium. It's called cesium.
Okay.
And it's cesium because it looks exactly like that weird blue color. It's like a very light whatever. And almost every X-ray machine, it's got a little ball of it about this big. It's powdery. It's like a solid whatever. And that's what an X-ray machine is. And then that is encapsulated in a lead capsule. And then on one side of that lead capsule is exactly how you would have a normal camera. Is it's got a shutter. It does this. It's literally a shutter. So you click on it, it goes just like a normal photograph does, right? When you get an X-ray done and you have that thing moving or you have that mobile X-ray or whatever, that's exactly what an X-ray machine is. It's a camera, but instead of film and you're exposing light radiation to film and you develop the water, it's cesium, and that black thing that they usually put behind you, that's lead. That cesium, those X-rays penetrate you, and the only thing it can penetrate is the densest part of you, which is bone. So just like the infrared, remember, we can't see X-rays. We can't see infrared. When you see an X-ray machine and someone X-rays you, you don't see the light that comes as opposed to the flash on a camera.
Correct.
You can see the flash because that's visible light. That's on the light spectrum.
You just hear the machine going, and you have the guy telling you, "Oh no, this is good. Just put this over your dick, and you'll be fine."
Yeah.
But then he fucking hides.
Yeah.
You know what I mean? It's like, just put this over your dick, and it's all good. It's all good. But
so that field of medicine is called radiology. And so you have the minimal ones are radiologist technicians, which are the people that just take the X-rays. And then you have interventional radiologists, which are the surgeons that use X-rays and stuff while they're doing surgery. So they'll be looking at an X-ray of you while they're like stapling your bones or like they're doing angioplasties or whatever. Like interventional radiologists, it's endoscopy basically. They put a little hole in you instead of cutting you open, which was what we did for 100 years.
Yeah.
We realized we can just put a little pin, put an X-ray or something that can see through you, and then you just kind of like see, and then it decreases the chance of infection, it decreases the chance of whatever.
Yeah, it's safer.
So that's what radiology is. Anywhere from technician to interventional radiology. And those are surgeons, then you can have real doctors, then you can have technicians, right? So they use X-rays. And that's what an X-ray is. It's a ray of beam that can literally penetrate you. All those X-rays are ripping right through your skin, and that's why you can see through it, and then hitting the lead shield, and then coming back at that camera. And that's all an X-ray camera is. That will cause cancer. A CT machine is about 150 X-rays done in about 20 seconds. So a CT or a CAT scan is if you've ever seen the machine, it looks like an MRI. It's covered in plastic, but in reality, what it is it's a camera. It's a camera that's on a rotating device, and that's why when you hear an MRI or a CT scan, it goes ooh. Yeah. It's because if you take that plastic covering off, it's actually a camera on a circle. It looks like a donut, and it just spins a lot. And what's that doing is, as it's spinning, it's taking photographs at every angle, and it's comparing it to make a 3D image of your arteries, of your skeleton, of your
Everything.
of your sonograms and CT scans are different because some of your organs are hollow, some of your organs are dense, some of them have gas in it, some of them have liquid in them, and different frequencies. Sonograms, which are safe, sonograms are in this area. They're safe. You can actually have a sonogram on you all
That's
day.
That's why they use those for pregnant women.
Exactly, literally that. Because a sonogram travels faster through water and liquid than it does through solid. So you can actually kind of see things easier through liquid. Now, if it's not that type of organ and you're not pregnant, you can do more invasive ones, which is X-ray, which will penetrate anything, solid, liquid, gas, whatever you want. So that's what a CT scan is. So it's doing in that donut, you're laying, so this is the circle, you're laying in it, and that camera is taking real fast, and then this is where graphics cards come in. The first graphics cards were built to take, it's like a reverse panorama shot. So you know how a panorama shot, you're standing still, and then you take a photo around you? A CT scan is the opposite. Is the target is inside of the field, and you do a reverse panorama. The first graphics cards took the 1,000 images that CT scan did, and then would process it to make one composite 3D image that doctors can then zoom in and zoom out. And that's how a graphics card was made. And the reason yours are so cheap, like a GTX 3090 is only $1,000, is because the first GTX real 3090 is meant to, the reason NVIDIA makes graphics cards is not for consumer gamers, it's for medical, it's for hospitals, it's for ground penetrating radars. That's what that's what petroleum companies do, is when they have those giant radars to check for oil, they're pumping out really strong radiation and then using graphics processors to map out what's underground for fracking, oil extraction, coal mining, things like iridium mining. Even for
Petroleum?
Oh, petroleum, no, but even for copper mining. And that's what these rays do. Gamma rays are even more powerful than X-rays, and you should never be exposed to gamma rays. It will give you cancer, regardless of what the
anybody will say.
Comic books tell you.
Yeah.
You will not gain powers. The mutations happen, what we call mutated cells. There's a name for it, and it's cancer. You don't gain powers, you get tumors.
Yeah.
That's what that is. So the second you're out of the visible spectrum and you can't see the light that's hitting you, which again, there's light hitting you right now. AM frequency, FM frequency. If someone's pointing an X-ray at us right now, we would know. Taking X-rays of us, CT scans, gamma rays shooting at us right now, we would have no idea. But we can only see this. This is safe. Anything above the visible spectrum will harm you. Obviously, this will harm you the least, and this will harm you the most. But constant exposure to this is why you get wrinkles, is why you get skin cancer. Minimal exposure to this, like eating cesium, taking fission material, like assassination, or uranium, plutonium, anything like that, without, and I'm talking lead shielding, we're talking like 4 inches of lead shielding thick. Like, and your whole body 4 inches thick. You can't be like, your whole body has to be, but you will get cancer. You will die.
Yeah.
There's a famous case in the 70s or in the 80s where a doctor's office, because 2 doctors sued each other in Brazil, they left an X-ray machine in the hospital building, and at the time there was a security guard posted. It's a very famous story, and it's actually in a book called Radiation. During the legal battle, the World Cup was playing or something, so the guard never showed up. Thieves broke in, took the X-ray machine, didn't realize it was an X-ray machine because it didn't look like one.
Yeah.
Broke it open, and then they saw the lead box, and they didn't know what it was. So they took a hammer, and it took forever, and they took the cesium out of it. And cesium is beautiful. It's this light color cyan powder, and they're like, what the fuck? This is the most beautiful thing. Bro, they put crosses on each other. They gave it, a girl ate some of it. Obviously.
They all died.
Obviously, 6 or 7 of them, the girl that ate it immediately died. Whatever. The Brazilian government secretly took one of the football stadiums and interned, I think, 2,500 people that they secretly did. So that's where contact tracing comes from, not from COVID. It was from X-ray. Yeah. They spoke to every single person, from the thieves to their families to which churches they went to. They rounded up thousands of people. The military overtook a soccer stadium, turned it into a whole field medical lab. They had to set up military decontamination things, which are those guys in the suits with the water shooting, clearing everybody. Dozens of people died. Thousands were, whatever. And to this day, you could develop cancer when you're 90 because of it, and when you're 80 because of it. So we still don't know what the damage is. But it's a very famous case.
When did this happen? I had no idea.
82, 83. It was covert. They never said anything until the late 90s, and by then it wasn't really such a big deal. But it was all done under the guise of secrecy. Yeah. Yeah.
Wow.
One doctor's office break-in led to the internment of thousands of people because two scavengers, this was in the slums somewhere, whatever. These two bums thought that they could get something for this powder. And his daughter ate some of it, and the wife,
Why would they fucking eat it, bro?
It looks great. The reason you don't see it,
a diamond looks great. I don't want to fucking eat it.
Yeah, so this was in the 80s. This was, I'm assuming, in some poor town somewhere with no internet, right?
Oh my god.
Yeah, it's a famous case study. So whenever you go into like a military internment, martial law, when you go into medicine, like exposure medicine, radiation, this is a case study that is often recited. In that it didn't end up being that bad. Only a couple people died.
A couple meaning
5 or 6, like really not as bad as bro. You open up, you put cesium on people's bodies, and you wipe around, you pass it around your church and shit. Like you're expecting 50 dead, 100 dead. Yeah. You know what I mean? Like it was a surprise. But the fear for nuclear technology is unwarranted because of Chernobyl. Things can go really bad, like Chernobyl did. That is Fukushima and Chernobyl. Chernobyl was the worst nuclear tragedy. It's the only level 5 tragedy that has ever existed. Fukushima's 4. It's also pretty bad. And where you can have hundreds of thousands of people in danger. Or you could have this one guy break into an X-ray machine and 5 or 6 people die. So this is all radiation. But all light, all heat is radiation. We just layman's call radiation when it's dangerous. Like that's a problem with 5G. Everyone thinks that 5G causes cancer. Everything that your phone uses you can't see it. So it's clearly not in this spectrum. And if your battery was shooting out UV, X-ray, or gamma rays, your battery would last about 2 fucking seconds because you can barely make a phone call for more than 10 hours.
Yeah, absolutely.
Yeah. The same thing with antennas. Like people who are afraid of 4G, 5G, whatever, you're right. You're putting radiation to your skull. And obviously, it's healthier not to have a source of radiation next to your skull than it is. But the chances of cancer are, 1, minimal, and 2, even if you get it, even if you're 1 in a bajillion, the radiation is not lethal, and you probably cut off 5 minutes in your life for a year's worth, a lifetime's worth of knowledge. Yeah, whatever. So that's why when you don't see light, when you don't see things, it's either very dangerous or it's benign. 9 out of 10 times it's benign because this happens outside of our planet, or when we make it inside of our planet, we have warning signs that say, warning.
Don't go here.
Radiation.
Don't touch this.
We have scientists. We have lead shielding. Marie Curie famously died of radiation poisoning after she discovered uranium. And she didn't even know either. But we learned our lesson. And that's why no one has to be worried about 5G because you would be it would be at such a cancer rate that there is no hide. It would be like COVID. You cannot hide 800,000 deaths. You can't hide it. It's impossible.
Now that you mentioned that, did you watch Don't Look Up already?
I didn't. I have to.
That's
see
fine.
It. Yeah.
We're not going to talk about it.
We're
not going to talk about it.
I want to see Spider-Man, so I didn't see it. I have to go to the Alamo, whatever the fuck you told me. Where is that?
I was telling you about the Alamo. It's they got 3 locations in New York. They have one in Yonkers, one in Lower Manhattan, and one in Brooklyn.
Okay. It's called Alamo what? Just the Alamo?
It's Alamo Draft House.
I have
And
to go on that.
even though they call it Draft House, they have a nice collection of beers, but I never really buy beers when I go
I'm
there.
there for the movies, bro.
Bro, it's just a nice movie theater.
Yeah.
And I think you should go because you don't like. This is by the way, for anybody watching, this is a different position that Stefan and me have in this particular topic. When I go watch a movie, as long as it's not a serious movie, let's say it's any kind of superhero movie, I actually like when people cheer, when people.
Oh no, I like cheering too.
I like when people clap when things happen.
No. Hold
What
on.
is it that you don't like?
No, bro, I don't know why, but every single time I go, I have 5 or 6 people. They're like, "Oh, he's stupid, man. He shouldn't fucking go in there." Oh yeah. I wouldn't fucking do that. That's what I'm talking about. I'm not talking about cheering. No, that's awesome. No, bro, literally, I had to stop Nat from like going after the people,
Fighting people,
bro. And what I mean, they didn't shut up. I mean, there was not one scene that walked by without Kurt. And I'm not making like, oh my god,
you're not
over.
exaggerating.
No. I'm saying when the camera went from one location onto another location,
There will be a new comment.
there was more than 0 words spoken. Now, I'm using very literal terms to describe the situation. The number of words spoken was greater than 0.
Yeah, so for anybody that doesn't know what we're talking about, the Alamo is this movie theater in New York City. Well, they're not in New York City. They're all over the country. Yeah. It's a franchise. Yeah. But this particular theater, one of their more characteristic things is that they don't let you get in if you're late and you cannot talk. And the reason it's easy for them to control this is because they have servers, they have waiters that go around checking on, because what they do is that you sit on your seat as any other movie theater, but you have a table in between you and the seat next to you, and that table has papers and pens. And if you want something, let's say you want more popcorn or more Coke, or you want another drink or food, because this particular theater, they offer different snacks and pizzas and pasta and whatever.
So it's a restaurant.
It's a restaurant theater. Correct. You sit down and whenever you want something, you grab a piece of paper, you write down what you want, and you put it there.
So it's not a drive-in; it's a walk-in.
Yeah, it's a walk-in movie theater that you sit and you get served as you watch your movie. But because there's so many servers, you're not only you're not allowed to talk, because every movie theater is like, yo, don't talk, put your phone on silence, turn it off, whatever. Not only you're not allowed to talk, but if you're talking, like if you talk and a server watches you, they'll give you one warning. They'll be like, this is your first warning. If you do it again, bro, you get kicked out. So nobody talks there. Nobody cheers. Like when
awesome.
When Captain America left
the hammer,
you couldn't cheer on that. You know
that's depressing. I don't want that.
You know what, bro? Again,
but it's worth the price of not having being fucking
exactly.
Because I'll tell you what, that movie what was it? I wanted to watch it. I was so mad I even forgot what I was watching. But it ruined and here's the thing, we were 45 minutes in by the time the brawl started. Yeah. Do you know how long it would take for me to get the appetite to go through 45 minutes of a movie I already watched? And mind you, I'm going to get angry just from remembering it. Then I got to go through half the movie to watch the second half of the movie that I didn't watch. They gave us, obviously, the lights turned on, and they gave us vouchers for like whatever.
That sucks.
But like, I don't care about cheer. No, I'm talking about
no, that will never happen there. They're very careful to as far as I've been able to observe, the Alamo, their main thing, or the main thing that worries them is that you're able to enjoy the movie.
I'll go for Spider-Man. Are they showing James Bond still? I don't think so.
Yeah.
Are they?
Yeah, they are.
Okay, I'll see James Bond in a normal theater. I'll see, because it's not good. I know it's not good.
I don't know.
I want it to be good, but it's not good.
Well, I mean, I watched Skyfall. I liked it a lot. I like it a lot.
No, bro. First of all, Casino Royale is the best James Bond.
Yeah, but I mean, from the last trilogy.
Yeah.
What's the name of this guy?
Daniel Craig.
Daniel Craig.
Yeah, so it's Casino Royale, Quantum of Solace, something else. Skyfall.
Before
five.
Skyfall, there's one.
Quantum Solace.
Is that with that guy?
No, I think that was after. No, it's Quantum Solace was after Skyfall. It was Casino Royale. Yeah. No, it's all James Bond.
These are books.
This is a fantasy. Just put in 007 movies. Put in all James Bond movies.
No, I got it. That song was so good.
That's Adele.
It usually says here the prequels.
Just say James Bond. Why you do this? James Bond movies. All James Bond movies. Movies, all. List of James Bond films.
Yeah, there you go.
Okay.
All right, so you got
Spectre. That was
Spectre.
Yeah, so
it was Skyfall, then Spectre, and then No Time to Die, which is the last one that I haven't seen yet.
Casino Royale was amazing.
Casino Royale was a fucking masterpiece.
I think was probably the worst fucking James Bond movie I've ever fucking seen.
Which one?
Life. Quantum of Solace. Was arguably, I think it's by far the worst movie I've ever seen in my. Actually, I want to see how much money it made. So let's say adjusted. Let's say adjusted 2000.
You mean you wanna know the box office?
No. It's got it right here. So box office, because it can't have 542.
Hey,
oh no, it didn't actually made less than. No, comments. I'll just look at. I just want to see what the ratings are.
This is not what you wanted?
Yeah, just the ratings. I just want to see Quantum Solace movie. Wiki, whatever. Bro, it was. That's generous. Six is generous. I've never fallen asleep at a James Bond movie before. Like,
it wasn't good.
I remember like doing one of these. Like, I remember just one.
What?
Bro.
You actually fell asleep watching
Bro,
it?
I didn't fall asleep, but I drifted off. Like,
for a second.
I started thinking about things not related to the giant thing that was going on, and it wasn't the lack of action, and it was the action sucked and the story sucked, and there wasn't enough of one, there wasn't enough of the other. Yeah, it was terrible. It was by far the worst James Bond movie. Skyfall was amazing. Spectre. What was Spectre? Oh, Spectre was with the Christoph Waltz as the bad guy.
Yeah.
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 I don't remember. That wasn't memorable. I don't remember it being bad or good. I was just really annoyed because he's such a good bad guy. Christoph Waltz is the ultimate antagonist. If I make a movie, there's going to be two people that are going to be the antagonists. Christoph Waltz, after I saw him with Inglourious Bastards. Andy Garcia, the Mexican-American actor. He's got the face. And then there's one British dude. Lord. Whatever Lord is. Something Lord. He played... Look him up. British actor, Lord.
Lord like this?
No. It's L-O-R-D. Like normal Lord. Yeah, British actor.
Stephen Lord?
Yeah, Stephen Lord.
Yeah. Stephen Lord.
Yeah. He... his face is just so you're an evil pile of shit motherfucker. Like, he's in his accent, and he's British, so all British people sound evil.
Yeah.
They either sound evil or like your
They have a way
grandma.
for it.
Yeah.
Well,
that's like a history for it.
Yeah.
But
like the U.S. narrative has helped because the British is always the bad.
the U.S. narrative, the Indian narrative, the
I know.
Canadian narrative,
the
African narrative,
the
I think
Argentinian narrative.
Yeah, I'm pretty sure is if you cut the U.S. out of it, they would still. Bro, you don't own a fourth of the planet at one point in time and get away with it. You know.
Absolutely.
A fourth.
Bro, I'll be honest with you. This has been amazing.
Yeah.
We're gonna have to fucking wrap it up, bro.
Yeah.
You've been the best, man.
Absolutely. Man.